Good morning, all. We've got about 3 minutes before we get started. Thanks so much for logging in and your interest in participating today, and we'll get started briefly, shortly. All right, good morning, everyone. I'm Tim Peters, the state engineer in Pennsylvania, and I have 8:30 on my clock, so we're going to get started so that we don't lose any time for the workshop today. Just want to welcome you and thank you for joining us. We appreciate it. And I think we have a good agenda of a variety of topics. And the topics were ones that were either requested or were volunteered. And so we really appreciate that. I will say that this workshop is something that we try to host at least once per year, usually annually. And so we're always accepting ideas for other topics or volunteers to give presentations. So reach out to me if that's something that you would like to do, or if you have ideas for other topics that we could cover that would be beneficial. Huge thanks to our presenters today. They're giving their time to prepare and then present, and I'm very thankful for that. And I'm also just thankful for the ag engineering, ag conservation partnership that happens. It happens across state lines, it happens within various agencies, and it happens with consultants and the private sector and different universities. So it's just fun to see that all come together. And this workshop is just another example of good partnering in Pennsylvania. A few logistics before we get started. I'm going to keep this brief and we'll go right into our first topic, but a few logistics. We will try to hold questions until the presenters have finished their presentations. So if you have a question, save it to the end. We'll give an opportunity to unmute your mic, or you can use the chat within Teams if you would like. Please keep your mics muted if you're not asking a question, and if someone goes unmuted for a period of time, I may go in and mute that person. So don't be alarmed if you get a notification that you've been muted. We are offering PE credits or PDHs for our PEs, and the original instruction that went out was to contact Paul Schaefer after the session. to obtain that information or self-certification form back. Paul has decided to move on to other opportunities, so we're going to pivot, and you should reach out to me. So if you have interest in obtaining PDHs for your PE license, please contact me after the session. And usually I get something back out to everyone who has requested it in about a week or so. So I'll try to do that relatively quickly. Let's see. I'll also note that we are recording this session, and the recording, it'll be available pretty quickly if you're an agency NRCS person. We'll be able to get that out quickly. If you're not from within NRCS, we'll still make that recording available, but it will take some time for our staff to get that uploaded onto YouTube or to a website. So we'll get it. Just give us some time. If you're interested in the link, reach out to me and we can make that happen. That's all I have for opening comments and logistics. So I'd like to move into our first presentation, and back by popular demand is Bill Lyons. Bill gave us a great talk last year on cold weather concreting, and so I had a lot of great feedback come back about Bill's presentation, and so we asked him to come back and give another talk within his expertise this year. Now, some of you probably remember, but Bill is a fellow in ACI, and he was the former chair of ACI 306, the cold weather concreting section, and that's what Bill gave his talk on last year. He's on the ACI Convention Committee, and he's a current Hot Topic Committee chair, and so very pertinent to his talk today. He is the 2018 recipient of the National Chapter Activities Award for his longtime dedication to the advancement and goals to the ACI chapters. And I could go on about his 38 years of experience in the concrete industry, but I would like to move into his presentation now. So, Bill, we really are happy to have you back. Thanks for being willing to do that, and we're looking forward to your talk. So go ahead and take it away, and you're welcome to turn off your camera at this point. People have seen you. It saves on bandwidth, so that's fine if you would prefer to turn that off. So, Bill.
Well, I'm glad to be invited back, Tim. It was a pleasure back in December of 2022, and I'm glad to be back here again. So let me just shut the camera off and go to the presentation. Okay,
We're good to
go here. We're good to go.
And, yes, absolutely, good to go.
All right, so thank you again, everyone, for coming. So my role with Euclid is business development from everywhere from Maine to Virginia, including Pennsylvania, and it gives me an opportunity to do a lot of traveling, and so my presentation is coming from a hotel. Anyway, just a 30-second commercial about Euclid. We are a manufacturer of admixtures that are going into concrete, everything from accelerators to retarders and superplasticizers, corrosion inhibitors, microsilica.
Bill, just one. Bill, I'm not seeing your presentation if you're sharing.
Okay, hang on then. Let's just go back to us.
Looks like I see it now. I see the PowerPoint.
Oh, you see it? Okay. Good to go now, Tim?
Good to go, Bill. Thanks.
Okay, my pleasure. Okay, so and also fiber reinforcement, which we'll talk about a little bit later, and everything that goes with construction products, everything that goes on top of concrete, everything from cure and seals to curing compounds and sealers and joint fillers and repair materials, damp proofings and epoxies as well. And we're part of the conglomerate called RPM, which includes everything from Tremco to Illbrook to DAP to Flowcrete and Stonehard, and 80 other companies are part of our conglomerate. Okay, now some of the learning objectives. We're going to talk a little bit about supplementary cementitious materials that are out in the marketplace, and then I'm going to go through what's going on as a phenomenon, and that's Portland limestone cement and how that is changing the whole concrete industry. And I'll talk a little bit about fibers versus welded wire fabric. All right, so what supplementary cementitious materials? Let's highlight that when you put water and cement together, two things are created. One is a calcium silicate hydrate, and that's basically the glue that binds everything together. Now, what comes along for a free ride that doesn't help anything is what they call calcium hydroxide. Now, we may see this calcium hydroxide as effervescence that permeates through old concrete, maybe abutments, maybe some brick as you see in the bottom. And that's really generally just a defect that's coming through over a period of years. It's basically the unhydrated lime, as I mentioned, comes along for a free ride. So supplementary cementitious materials, such as fly ashes and slags and silica fumes and metakaolin, what they end up doing is they react with the calcium hydroxide, unhydrated lime, to create more glue. So basically, they're just filling in the capillaries and reacting with that calcium hydroxide and making it a more more glue to the concrete matrix. And what that does, it gives you good benefits, including strengths and permeability. Okay, so first, fly ash, which has been around since the 1930s in the Hoover Dam, is basically the residue from a coal-burning power plant. Dosage rates generally are somewhere between 10 to 40% for type F ash, which is utilized in a lot of the old plants that were done in Pennsylvania. But mostly in the east, it would be type F ash. In this central part of the United States, type C ash is be more common. It's a little darker in color. And so, well, the good thing about it is it's spherical in size. So what that does is that actually helps with the workability. If you took a cement content in a cubic yard of concrete of, say, 600 pounds of cement, and you worked it out with the water cement ratio to give you a 4-inch slump, if I included fly ash in that mix and say, take out 100 pounds of normal cement and put 120 pounds of fly ash, because you need to make sure the specific gravity of the to meet the 27 cubic feet per cubic yard. So you take out the 100 pounds of cement, put 120 pounds of fly ash in, and now all of a sudden you get a 5-inch slump. And that's all because of the ball bearing effect of the spherical particle size. It's a very cost-effective substitute for Portland cement, and that's a good thing as far as cost. Two, as also recognized as an environmentally friendly material. We're utilizing a byproduct, and now we're putting it into something that we use every day, and that's a good thing. We also know that Portland cement is very high embodied energy, which I'll talk about in a second. So all these things are very good for the word sustainability. Other benefits is including higher strength gains. Remember, if I have 600 pounds of cement and I take out some cement to put fly ash in, I'm reducing the initial glue, and so my initial strengths are a little bit lower. People say fly ash is a retarder. No, I'm taking out some glue, and over time, my strengths start as the materials start to come together, the strengths will go up. So therefore, fly ash mixes, generally continually gain strength 56, 90 days, and so on. They produce a denser concrete for smooth surfaces. So a lot of DOTs, a lot of public agencies use it for reduced permeability in their bridge decks. As I mentioned, increased workability, reduces bleeding, and allows for slower heat of hydration. Okay, now it's 90 degrees. It's for 2 weeks. The cement's doing what it's supposed to do. The heat of hydration is heating up. The fly ash will slow that down, and everybody can construct their applications with concrete a little bit better. Now the problem is, why can't we get as much fly ash as we used to? And I used to sell fly ash back in the early 2000s, and the only problem I had is trucking. We didn't have enough trucks, and that was a good thing. I used to sell ash right out of York, PA, right out of Sunbury. It was in great demand, but now we don't have as much fly ash. 3 reasons why. Natural gas. As a coal burning power plant, as I would like to say this to my architect friends, the coal burning power plant doesn't care about your LEED building or your platinum accreditation. Okay, they sell power, and if a facility can turn over from coal to natural gas, as they did in York about 10 years ago, then therefore there's less ash out there in the marketplace. I'm not sure if anyone recalls in 2022, President Biden was in Fall River, Massachusetts, and he was touting a climate control presentation, I guess, talking about renewable energy, and that power plant was a big supplier of fly ash for the big dig in Boston in the 90s and early 2000s, and that plant has been torn down, and they put a natural gas plant in there. So therefore they're wiped out a big source of fly ash in the Massachusetts, New England marketplace. Number two, the rise of renewable energy. Who has not gone down on the on roadways or along the coast? Okay, there's a bunch of wind farms or so, and that's great for renewable energy. Again, it's just another way to reduce the fossil fuel generators. And number three, environmental regulations. The government, the EPA, is doing their job. They're going into these coal burning power plants, and they're saying, hey, owner, you need to do this, you need to do that, you got to, fix this, put some scrubbers in, clean this all up, okay? And that's costing tens of millions of dollars. And the owners of these power plants are saying, I don't have the $50 million to add on to this. We're just going to mothball the plants. And that's what happened to a plant over in Sunbury. So all three of these reasons are the reasons why we're utilizing less fly ash in the marketplace. But the good thing is we're talking about harvesting of fly ash. For so many years in the 40s, the 50s, 60s, 70s, the power plants would take in this fly ash and they were, just putting it into ponds, or they were putting it into landfills. And all of a sudden, now we're realizing, hey, that's good ash. Let's take this ash, clean it a little bit, and put it back into the marketplace. And it's a great thing for both fly and bottom ash, which is a little bit more, thicker and bigger particle size. But we can even have more land to use other things for. So it's a good deal for the fly ash industry to recapture, but they like to use the word harvest. Then we move on to the next supplementary cementitious material, and that's called ground granulated blast furnace slag, or for simplistic reasons, I'll just call it slag. And the slag is coming from the steel industry. And it is definitely a lot lighter than fly ash, and it's a lot lighter than cement industry. According to ASTM C989, dosage rates are generally in the 20 to 50%. I say higher for mass concrete. If you were doing some type of a mat foundation, 6 feet, 8 feet, 10 feet thick, okay. Therefore, you don't want the heat to build up. Higher dosage rates, according to ACI 207, is approximately 70 to 80% of slag content for those applications. But if you take a look at this on the left-hand side, you see general concrete applications, whether it's pavement, whether it's floors, whether it's block, whether it's ASR, whether it's tilt-up panels. Most concretes are generally utilizing 25 to 50% on a daily basis, all day long. Okay, works out very well for the industry, and no issues at all. Other benefits for slag include the same thing as fly ash: higher strength gain. Again, it's going to react with the calcium hydroxide to form more glue. Reduce the heat of hydration. Okay, more of a smoother surface or sharper detail when they're finishing the concrete. As I mentioned, lighter in color, but at the bottom, it helps. Slag also helps mitigate for ASR, and ASR comes from the aggregates. Certainly, PennDOT has certain requirements to meet ASR. and there's certain quarries that, have to do other things for their aggregates to be utilized. It also was used slag as a system to improve sulfate attack as well. So both are quite different than utilizing fly ash. I just took a snapshot of a large building. This is called the Central Park Tower. It's right there in the middle of some of the tallest buildings in the world. Well, there's the Burj Khalifa on the far left. Okay, the Petronas Towers on the right. Okay, right in the middle is the Central Park Tower, and on the bottom left is just 7 floors of Nordstrom Towers, Nordstrom store. And to reach the strengths of 14,000 psi concrete in 56 days, they utilize 4 different cementitious materials to meet that 14,000 psi concrete. And generally what happens is the higher the strength that is designed, say 10,000 going up to 14, the higher the strength design, the less cement being used. So I could tell you, honestly, probably this kind of mix at 10,000 PSI probably started at 475 pounds of cement. And then, 12,000 went to 400 and 14,000 went to 350. Completely different from all the knowledge and studies that we've always had. Higher strengths, you put more cement in. That's not the way it works. The higher the strengths, the less cement, and the more supplementary cementitious materials. The items in red are just the amount of admixtures being put in, because look at the bottom. You need to meet a 0.27 water cement ratio, and you need to have a spread of 26 inches for workability, because that concrete has to be pumped 1,000 feet. Okay, moving right along. This is one of the most exciting things that has come out in recent years. Ground granulated glass. So take your Heineken bottle that you had last Saturday night, or maybe somebody had a delicious bottle of wine with your significant other, and or on Sunday, you're watching the football games. You took a couple of pickle jars out and you're putting them around the table or so. Take all those jars and bottles, and we're going to ground them up, because we're going to put them into concrete. So certainly the glass has been a big issue. What do we do with it all? It's just another landfill for many years. Well, now we're taking it and we're putting it into concrete. We're taking it and grounding it, and we're going to pulverize it. And I say we, the industry is pulverizing it, and it makes it into a very fine, the same sort of size of slag, and also it becomes it's light color, so it's almost very close to the slag in color as it is. So companies that have started doing this anywhere from the last 10 to 12 years are now able to utilize ground granulated pozzolan, or ground glass pozzolan. I keep getting my acronyms incorrect. And really makes the concrete more sustainable and easy to work with. It also creates a very high-performing, longer-lasting concrete with following attributes. So obviously, it's a dramatic reduction of your carbon footprint, and it has adhesion of aggregates to the cement paste, creating a really strong paste. Again, as I mentioned, it's a white pozzolan, so that's great for surface reflectivity and reduce that urban heat island effect. So it's regionally made from post-consumer glass, so that people can utilize that for lead, and it can now be utilized in high-performance mixes to reduce permeability or increase compressive strengths. Here's a couple of projects that have been in construction over the last 6 months in Torrington, Connecticut. I had a firm that was very interested in knowing more about what's going on in sustainability. And Bill, what are you hearing about sustainability? And I said, well, there's this new phenomenon about ground granulated glass. And so they actually went out and toured the facility and liked it so much they ended up putting it in their specifications. And lo and behold, a producer was already using it. And anyway, these schools utilized ground glass pozzolan in all of their slabs. for both the middle and high schools for Torrington, Connecticut. It's also been utilized, United Nations, okay, where they put it in some materials there. They also utilize it in some CMUs for in subways and for the metropolitan transportation in New York. And they used it over here. You might have saw a picture of it a couple slides back, and on the right-hand side, Hallett's Point. And that's what happened here is one design firm did a lot of studies on utilizing the material, and then was confident enough that they utilized it after a 30-story building. Hey, you know what? We're gonna put it in a 1,240-foot tall building with the owner J.P. Morgan Chase. So this is again, large building for a headquarters for J.P. Morgan Chase in Manhattan. It had 16,000 psi concrete in the base, but all of the slabs had anywhere between 8,000 to 5,000 psi strengths. Again, it wasn't utilized for permeability, but it was utilized, as a post-consumer material, and it worked out very well for this firm. And the project is just about topped out, and I think all manners are looking for another opportunity. Now, the thing about the glass is, most most concrete producers, for those who have been in a concrete plant, have at least 3 silos. They usually have a minimum 2 for cement and 1 for a pozzolan, because you got to have 2 for cement, because in case if you only have 1 cement and that silo breaks down, you're out of business. You can't do anything. So you always have 2. Now, sometimes, depending on the size of the plant, they may have 4. So 2 for cement and maybe 2 for pozzolans, or wherever they go. So if someone wants to utilize this glass on a job and say, okay, we're gonna do this backyard, we're gonna do this plaza. It's 50 to 100 yards on this. A concrete plant, cannot store 2 tons in a silo to tie up the job. They need it generally bulk. Okay, so it has to be a bigger silo. So this particular plant, which is an urban plant that did this, had 5 or 6 different silos, so they could dedicate a silo to ground granulated glass. ASTM has come up with some own studies, and so has ACI has published a paper. If you like that, send me an email at the end of the conference, and we'll be glad to send it to you. But what I'm saying is these our industry standards, they're out and about, and they're putting it into form. Okay, now I'm going to move along to Portland limestone cements. Very interesting topic. I was on with somebody yesterday who his mind was just taking off. He could not believe what I was telling him about Portland limestone cement and where it is. But I'm going to tell you, because when you make Portland cement, it's a really high energized intensity experience, okay, between the mining, blending, grinding, burning, finish grinding. Okay, a lot of energy is put forth when this material is being made, just so in order for it to come out in a bag or come out in a cement truck and delivered to a concrete plant. So, excuse me. What Portland limestone cement is actually just increasing the amount of limestone that's already in our regular Portland cement. That's all it is. We're adding up to 10% more limestone, and what that's doing is it's lowering our carbon footprint. As I mentioned, we're only adding, it's already had ASTM C150, our normal Portland cement already has 5% limestone in it, and now all we're doing is adding another some 5 up to 15% limestone. But generally, the cement manufacturers are targeting just 10% limestone. Now, here's the history. In 2004, ASTM, approved the use of 5% limestone in all C150 cements. didn't impact anything that we wanted as an owner, as a contractor, as an engineer, as a supplier. Didn't affect anything as far as setting times, water cement ratio, compressive strengths, workability, and had no effect. In 2012, they said, okay, we're going to add up to 15% limestone, but we're going to call it hydraulic blended cement, and we're going to call it ASTM C595 in 2012. Nobody did anything. Nobody did anything until 2022, when the major cement producers announced, hey, we are going to change from ASTM C150 and we're going to go to Type 1L. And that's when the proverbial hit the fan, if you know what I mean. Because in March of 2022, at the ACI convention, and there's a lot of smart people that are on ASTM, ACI 302, which is construction of slab on grades. And in ACI 360 is design of slab on grades. Nobody said a word because we didn't know anything about Portland limestone cement. But that 6 months window, by the time they got back together in October, there was a lot of gnashing of teeth, putting fingernails on chalkboards, a lot of pounding of tables. We don't like this stuff. We don't want to use this anymore. And that's not happening. And it's still gnashing of the teeth. Why does this Portland limestone, what's the benefit? Well, it has a lot to do with particle packing. If I have this limestone, which is a little lighter and than other materials, can actually fill in some of the voids. They call this thing nucleation, which is basically helping with the hydration process. And the third reason is some type of chemical reaction that is really hard to pinpoint, but the cement industry said there's a little better cement reaction. That's good. Hey, the DOTs, okay, and the DOTs really rule. They started, understanding it, accepting it, because the cement industry says we're not going backwards, we're going forward, and that's a good thing for the environment, right? It's all about sustainability. That's why we're here. So Portland Cement Association, PCA, has a 2050 roadmap to carbon neutrality. If you're interested in this stuff, it's a good 50-page read. Okay, the idea is that the cement industry is trying to do a lot to get to 2050. Just like the Structural Engineers Association, they have their own SCA 2050 as well. So the Portland Cement Association is trying to get there, and we're going to reduce our carbon input. Okay, so right now you have ASTM C150, okay, your normal type bonds and your type 2, maybe your type 2 1-2 blends, okay, maybe some people are still making high early strength type 3s, not as much as they used to, okay, that's going to go away sooner than later. I was, one engineering firm called me last February in Maryland, said, hey, Bill, we're getting this a line of stuff on. We can't get any more C150. Is there any truth to that? I said, hell yeah. Some areas of the country it's not available anymore. A cement manufacturer is not going to make C150 Monday, Tuesday, and Wednesday, and then C595 the rest of the week. Once they start, they're all in. And as you can see, the C595, you see the 1S slag cement, 1P Portland cement with fly ash, a 1T an ash, a slag, and limestone. You see what I'm seeing? You see what I see? I see a lot of joining forces. Okay, what that means it'll be all that's going in one mix. And what you will eventually you will only see Portland type 1S and 1P or 1T if you can get it. They're just condensing everything. Here's the value, okay? Let's go back to 2019, okay? We would have reduced the CO2 emissions by 8 million tons if we had Portland limestone cement. So you see the value what the environment's going to have with the impact of PLC. Canada is already well into it for years. Europe is well into it for years. the United States, a little on the slow side, but we're ramping it up rapidly. So what I tell individual companies or so, you need to put in your specifications, if you don't have it already, is have two different types of cements in your specifications. So you have your ASTM C150s, and then you have your hydraulic blended ASTM C595. So Tim, I'm going to use your location as an example. Okay. So if I'm in Harrisburg and you come up with a job and there's two concrete producers other than, in that marketplace, I know there's more, but if there's two concrete producers in that marketplace and you as a specifier only specify C595, but one of those concrete suppliers only has ASTM C150 and another one has C595, well, the C150 guy is not going to be able to bid anything. And that ASTM C595, he's going to increase his price because you have limited it to just that one type of cement. So until everybody's in and everybody's making C595 and we're all equal for the time being, I would recommend having both products in the specifications, and that's what's been going on. You want to write something down? greenercement.com. They're utilizing this calculator. You can plug in some of the savings you can use per job. A nice little tool, and it's a good thing. So what's so fine and dandy about ASTM C150 and ASTM C595? Fine, I'll tell you fine. Let me go backwards here. Generally, the Portland limestone cements are ground a little finer. So what happens when the concrete cement is ground finer? It can become a little more thirsty, which means if you want to specify a certain workability, you may need a little bit more water in that mix to get to that same workability. If you specify 4,000 PSI concrete and a concrete producer doesn't need to say, hey, you know what? They're really nice people. I like those people a lot. I'm going to give them 5,000 PSI because, they send me a Christmas card. Okay. They wish me a happy birthday. Okay. No, they don't have to do that. They have to give you 4,005. So if I'm have to add a little bit more water to get to that workability, maybe 2 to 3 gallons per yard. Therefore, the general rule of thumb, for every gallon of water you add, it's a reduction of 150 to 200 PSI. So all of a sudden I add 2 to 3 gallons of water. Now I lost 300 PSI, and now I'm down to 3,700 PSI. Now you're not meeting the requirements. Well, something's wrong here. So there's a lot of maneuvering out in the field. So one way to take care of that is you may need a little bit more cement. Whoa. Hey, more cement means more, that's not sustainable. That's one way. Second way is you lower your water cement ratio. You go from 0.45 to 0.44. Well, that takes some water out of the mix, but or you could add more cement to that and it balances out. Or you add a little bit more admixture, generally marginal amount of differences. Either way, the concrete plants that have a good quality control department dial in those mixes. But they really could change. See, the Portland Cement Association said, hey, it's just a 1-to-1 ratio. As I mentioned, it could be a little bit more finer, and therefore it could be more, needs a little bit of more liquid to it. Again, same kind of dosage rates as you normally utilize for fly ash and slags. That doesn't change. Air content, slump certainly could change, but air content really hasn't seen any much of a difference there. So it just means doing some diligence in the mix designs ahead of time instead of worry about it in the field. Again, workability, that changes. The bleeding really has generally no concerns. Setting times, okay. I haven't seen any change there. The compression strength, again, reflected on the amount of water that you put in there as well. Again, it's sulfate resistant, really hasn't any change there. Okay, so now I'm going to wrap this up in this way here. Utilizing fibers to reduce the floor footprint in concrete. Listen, the use of fibers in the industry goes back 40 plus years. And they were generally accepted by International Code Committee, UL, Steel Deck Institute, ACI. There's a lot of different materials out there, but there's micros and macro fibers. These are the synthetic fibers that are utilized in the marketplace. And fibers have been utilized from everything from toppings, okay, on a library on the bottom left-hand side where they had radiant heat. And, you could put welded wire fabric on that. Okay, it's a library. You got kids. I got grandkids. I don't want little pieces of welded wire fabric sticking out of the slab. So they utilize fibers in that application. On an elevated deck, okay, they can, the contractors can pour and place a lot faster. And buildings, certainly that 20-story buildings plus, large convention centers that are utilized for fibers, polished concretes, okay, and in stores. Your Home Depots as well could do that. Have concrete with fibers, even as big as jobs as Tesla. 8 million square feet. You know how big 8 million square feet is. That's a lot. That's a lot of concrete that was going in, while utilizing fibers. I like putting this in because I knew a professor, Dr. Richard Wires from Virginia Tech, a longtime friend of mine. I always put this building in my presentations just because him and I go back a long time, but they utilize now fibers in this type of project. Lucas Museum, if anybody gets out to San Francisco area, okay, that was utilized as well. Just a wonderful structure. And anybody who's gone to the Super Bowl a couple of years back or watched it, let's put it this way, we watched it. SoFi Stadium also utilized that in the concourse areas, and that was kind of neat. And last but not least, Yankee Stadium, it was utilized again in the concourse areas. And I put this in as a sort of a little levity here. We all, in this day and age, we need a little levity. There was, I don't know whether anybody remembers the story. There was a worker there who was a big Red Sox fan, and we're talking about 2007 or so, and he buries the Ortiz jersey in the concrete. Well, sounds like a great story, but you have to tell somebody, right? You have to tell somebody at work, and that tells somebody, and it got around. Excuse me, and it got around, and until George Steinbrenner was still alive at the time, wait, we got to find that guy, where he put that jersey. Okay, they had to do an autopsy of where did he work that certain day to find that jersey. And when they did, they had a hell of a time trying to get the jersey out because of all the fibers in the concrete. I hope you have some fun with that little story. Anyway, the synthetic macrofibers used to replace steel reinforcements all over, whether it's slab on grade, slab on decks. They're just there for temperature and shrinkage. They're not there for structural purposes. And about 10, 12 years ago, there's a tool out to help the A&E industry and contractors calculate that GHG emissions reduction as well. And now we can quantify the savings and the global warming potential, okay, versus steel. So it's a form, okay, that can be filled out. And again, we're just trying to utilize that carbon footprint calculator, and you can reduce your GHG by reinforcing by over 50%. So it's a good tool, and it comes with a paper as well, from the University of Akron. Another good thing that's out there in the marketplace here for fibers, okay, to be just so you have it as a holding point, is your EPDs, your environmental product declarations, okay. So those out there, some manufacturers have that specific for a type 3 EPDs for both either micros or macro fibers. So that's another material. I think Jennifer talks a little bit more about GHG emissions later on in the presentations. Again, there's also programs out there that if you provide the bar diameter or spacing or slab thickness, concrete strength, steel strength, and a reinforcement depth, you supply all of those, you could figure out what the actual fiber dosage rate would be. And again, that's sort of helping out the environment as well. Last thing I'm going to talk about is reducing the potential for plastic shrinkage. How does plastic shrinkage out? Again, this is just a quick slide on microfibers versus macrofibers in the 1/8 inch to 3/4 inch to 1.5 inches to 2 inches for macrofibers. But plastic shrinkage happens when the possibly wind comes across and dries that top surface. And taking whatever moisture was in that is trying to bleed up through the concrete and dries that out while the bottom is still plastic. And they call this many years, a jelly sandwich or so, or it's crusting over or so. But you can actually see these plastic shrinkage cracks, right during the middle of the final finishing. And as you can see on the bottom, it has all these little squiggly lines. And I think what happened here was it was certainly a bridge deck or so, and those who do bridge decks understand, but you have to have generally on bridge decks, you have a wet cure and wet burlap. Well, the wet burlap probably was not secure, and then it could have been done on a Friday, this job, and it blew off, causing that rest of that concrete to just to have plastic shrinkage cracks. The integrity of the concrete is fine, right? It's nothing's going to happen to it. Compressor strength's going to mean all that stuff, but the top surface has got some new decorative concrete. And as an owner, nobody likes to take a look at the use of plastic shrinkage crack in my brand new application. Somebody dropped a ball. Owners don't like that type of thing. But anybody, I'm going to see how many on the call are a movie buff with the upcoming Oscars and everything. In 1967, Mike Nichols, who won the Best Directors Award for there, had the movie called The Graduate. Dustin Hoffman, and Bancroft were the two stars, and a lot of people that got out of college, they don't know what they're going to do, and Benjamin is laying in his father's pool, and his neighbor comes over and he says, "Benjamin, I got one word for you. One word: plastics. Plastics." So what do I mean by plastics? So we all drink this Poland Spring and Arcadius and things like that. We drink a lot of bottles of water and we just toss it. So now what we're doing is we're manufacturing from these bottles. We are making them into fibers. We're taking that plastic bottle, which I was given at the hotel last night as a diamond member here, Mr. Lyons. You get 2 bottles of water, and they're taking that bottle, crushing it, making it into flake, melting it into a resin, and then putting it back into a fiber that is approximately 1/4 inch thick. And now we're putting them in to reduce our plastic shrinkage cracking. Okay. Just a great deal. So now I got 190 plastic bottles. I could put them in a 20-pound box, and let's put it this way: each yard of concrete is a half a pound. So I got a 10-yard truck. You see a 10-yard truck of concrete going down the road. It's 5 bottles in there that could be utilized for plastic shrinkage cracking. So a pretty neat concept that is starting to take off and get some good things. So this is the slide that I used that shows that it's about a mile from where I live, right over a beautiful trestle. When I'm taking a train, I can take that, and that's how it looks in the middle of the fall. It's a beautiful look, and to me, it tells me that damn, summer's over and winter's coming. So anyway, in conclusion, okay. The concrete industry is really changing. Okay, we're now taking glass, we're taking plastic bottles, we are changing the cement makeup. We're harvesting ponds of fly ash or so, making it into concrete is really changing rapidly over the last few years. And for so many years, it was just very little change. And now the concrete is really trying to be sustainable. So again, I thank Tim for the kind words and the opportunity to present.
Hey, thanks a lot, Bill. If anyone has questions, feel free to use the chat. And as an alternative, one could raise their hand in Teams and we could call on you, while some others might be thinking of questions. Bill, I did have a question for you related to the Type 1L cement. So our national office within NRCS has approved Type 1L, and we found that this past year, that was our only option. And some locations within Pennsylvania, as you noted, would happen. But the national office has approved use of 1L with up to 10% cement. Since the spec goes to 15%, any concerns you have at that 10 to 15% amount, or any data that you have? The national office, they weren't necessarily opposed to going higher. They just indicated to me that they really didn't have data to reflect that was a good number, but up to 10%, there seemed to be more data that they were comfortable with. So thoughts on that, Bill?
Okay, so thanks for the question, Tim. So as I mentioned, the cement manufacturers, they're targeting 10%. Okay, they're not all of them, they're targeting 10%. Knowing that sometimes it could be a 10 or 12. It doesn't matter, because if it's ASTM C595, and it meets that, it means 5 to 15%. It's got to be in that window. So I'm not sure I agree with limiting it to 10, because maybe one supplier can do the 10%. Again, they're targeting the 10%. Other suppliers may be targeting a little bit more. And again, if you only use it up to 10%, and then there's 2 cement manufacturers or 3 cement manufacturers in your marketplace, then you've excluded those other people, because they're at 12% or 13% or 6%. That they'll follow, they'll be in. So as long as it meets ASTM C595 and that falls between 5 to 15, they should be all utilized. I mean, because you only limit it to 10%. Again, you saw the pictures of how cement is made. I mean, it's close. It's so close, but they can't. Sometimes you can't be that accurate. It's like having an air entrainment be specified. I want 5.5% air content. Well, geez, I mean, that's it may be 5.2. It may be 5.8. It's right. It's in that. It should be close. It's close enough. No, then you really maybe pushing those other ones out.
Mm-hmm. Very good. Thanks for that response. I appreciate that. We have 2 other good questions in the chat. First one: are there any extra dangers to breathing the dust from concrete with these additives when cutting or grinding or demolition? I'm thinking this person was thinking especially of the ground glass and plastics. That's an interesting question.
Again, these materials, okay, like I'll put the plastic off to the side. The ground glass, since it's a pozzolan, okay, it immediately reacts with that with the calcium hydroxide, so it's part of the matrix. So it's going to be within 10 14 days you don't even see it. Okay, it's all part of the matrix, so it's not really an issue. But I would always follow. I don't care. You have to need the proper face mask and whatever you have to do to protect yourself. That goes without saying. I mean, nobody who is cutting concrete should not have the proper material just to protect themselves. I don't see whether it's anything that's in the concrete, ash or glass or anything. It's ground. I mean, listen, I've touched that glass. Okay, it's like putting a hand in a whole bunch of cement. It's all powder. It's like talcum powder, right? It's light. I'm definitely not breathing anything in, but I wasn't afraid of it. I just, okay, well, where's the water? I'll wash it off now.
Very good. Thanks. Next question. Is there a recommended maximum amount of slag in a concrete mix? Do you have a thought on too much slag?
Okay, I posted this little dosage rates or so, per applications. So again, the more slag you put in, which means you'll have less cement. So it's certainly not going to set up as fast. You're not going to gain your strengths as much. What are some of the other reasons for concrete desetting times? Well, maybe I need to have it, formed up faster. Maybe I need to have shoring up faster. You put more in because it's sustainable, but then you don't reach your strengths further out. That could extend the construction period for that job. And people get jobs because I want to build it faster. I got a tenant moving in. I've got things that need to be put in. So we don't want to add more time to do that. So it all depends on how much you don't really need. You need some slag because it's good for the industry and it's sustainable. You put too much in, it's not gonna set up as fast, and you got other issues. Now I did put down, for mass concrete, anywhere that 70 to 80% is what I've seen in the past as high of, and that's not going anywhere with that kind of mat foundation or walls. I'm doing a job out in the West Coast. They're looking at 10 feet thick walls. This is for shielding. Okay, so they're going to build those walls. They don't care how much. They don't care when it sets. Okay, they're not going anywhere with that material. The other thing too, very quickly, is somebody asked me this yesterday. I said, he asked about cost, right? And I think cost is always a big factor. Okay, but as we reduce the amount of coal burning power plants, okay, and we utilize and need more slag in our concrete mixes, to be sustainable, right, and to be environmentally in tune. Slag costs more than cement now because it becomes supply and demand. I need more slag, so you demand more, so we're going to charge more. And so fly ash is still less than per ton than cement, but slag is a little bit more expensive than cement. And glass is somewhere in between. Again, we're still early on the glass, okay? But in this industry and as in others, monkey see, monkey do, okay? And somebody has some investment and they're putting it in, they're building around the country. It's going to only grow.
Very good. Thanks, Bill. A few more questions. The next one. Should we be more worried about a long-term sand shortage? Do you have thoughts on that? Sand being an issue.
You know what? It's so funny. I was speaking to my father-in-law yesterday. He was reading this article in some kind of magazine, science magazine, and they were talking about harvesting the sand in Africa and how the shortage. And I said, yeah, if it's good sand, because we're running out of sand. We're just running out of sand. We're using concrete, using asphalt. CMU, whatever it is, we're running out of places for sand. So it's not an issue in 2024. I don't know how many generations out, but there is we're just running out of places.
Mm-hmm. Very good. Yeah, thanks. And then last question right now is, this piggybacks on an earlier question. Is any amount of concrete dust okay to breathe in? Is there a daily maximum limit that changes with the differing products that are ground into the cement?
Tim, I don't have that. I don't have that information. As a material supplier, I don't have it. Geez, I got this really bad cough lately. No, I have no idea how that is. That would be more somebody else's field. I wouldn't even venture to take a question on it. But certainly, there's a lot of people that have been working in it for years and years.
Yeah, thanks. Maybe a topic for next year's workshop. So thanks for that response. We appreciate it. That's all I have as for questions in the chats. We greatly appreciate, Bill, your time and your presentation. Very pertinent information for us right now within the NRCS and our partners and consultants in Pennsylvania and surrounding states. So thank you very much. Just like last year, we greatly appreciate it.
My pleasure, Tim. If anybody wants me to needs me for other information or so, I'll be glad to. Yeah, Tim has my information. I was on the first slide, and be glad to come by and meet as well. Thank you very much, Tim.
Thank you, Bill. All right. Thank you, Bill. Transitioning now, do we have Jennifer Whiteman on the call? Jenny, are you on? Looks like we do. So thanks, Jenny. I appreciate it. I want to do a quick introduction of Jennifer Whiteman's, and Jennifer is with the Cornell College of Agriculture and Life Sciences. And I asked her to give a talk on covers and flares and the impact to greenhouse gases. And Pennsylvania NRCS, we saw this as an opportunity to address greenhouse gas issues that we all know are happening, and the covers and flares were an item that Pennsylvania and our state con in Pennsylvania really made a big effort to get on our climate smart list within NRCS. So that did happen about a year ago, and that is on the list. And so we wanted to highlight what we're talking about and the benefits. So Jenny comes from Cornell, as I mentioned, and for the last 2 decades, she has focused on the systems-based greenhouse gas mitigation strategies for agriculture, forestry, energy, and waste. And most recently, she has been the co-lead of the greenhouse gas inventory, mitigation, and future scenarios for the agricultural sector to assist New York State Department of Environmental Conservation in meeting its mandate to reduce greenhouse gases by 40% by 2030. Sorry, 2030. So thank you, Jenny. We really appreciate having you and looking forward to your talk on covers and flares and greenhouse gas mitigation. So with that, I'll turn it over to you.
Can you see the screen okay?
I can, yes, thank you.
I love that when that happens. All right, thanks, Tim, for having me come. I'm going to talk about the New York State policy as well as the greenhouse gas inventory in order to make the case for why cover and flare is such a key opportunity in New York State, which is a very large dairy industry state. Okay, so here's the overview of the talk. I'm going to talk about what is called the CLCPA, the Climate Leadership and Community Protection Act, that was signed into law in 2019 in New York State. I'm going to then briefly talk about the total state inventory and then hone in on our ag sector inventory. And then we'll focus on manure management and how we can address greenhouse gases for manure management. So anybody can look at this act. I just wanted here so you have it. But basically, the high level content says that all sectors must achieve a 40% reduction in greenhouse gases by 2030. So apartment buildings, industry, agriculture, right, you name it, every sector needs to reduce its emissions 40% by 2030. And this is below 1990 levels. And 85% of greenhouse gases by 2050 below 1990 levels. Then the final goal is that by 2050 we're net neutral. And so that what that means is the 85% reduction means that there's 15% of hard to decarbonize fuels, such as jet fuel. And so we need to be net neutral. And the way we could do that is we could use our forest land to sequester carbon and build out long-lived wood products, for example. And that would make up a mass carbon sequestration to accommodate those hard to decarbonize fuels like jet fuel. There's a whole sequence of events that New York State is going through, but they've come up with their inventory. In their first inventory their new inventory was in 2020, and then they had a scoping plan in 2022. And by 2024, DEC has to come up with its formal policy of rules and regulations for all parties. How are we going to do this? Well, we have to do it cost effectively. And so New York State did a social cost of carbon, meaning the cost to future generations if we do nothing, meaning future damages to infrastructure, future damages to homes. How much is it going to cost New Yorkers if we do nothing? And they determined less than $130 per metric ton of greenhouse gas reductions is cost effective. We need to do these greenhouse gas mitigation impacts without co-pollutants. We need to do it equitably. There's a whole range of topics on how they define equitably. And the mitigation must be real, permanent, quantifiable, verifiable, and enforceable. And I can talk a whole lecture about what these words mean and why they're so important. I just want to pull them out so that when you hear them, you don't think of them as just normal words. They actually have accounting meaning that is specific to greenhouse gases. How do we get there? So in 2022, New York State published a 445-page document, which was a massive democratic action. So there were key stakeholders in each sector. There were 22 stakeholders in New York State for just agriculture and forestry, right? So each sector had these focus groups to come up with this scoping plan. And one example of how we get there equitably was this Diversity and Racial Equity Working Group report released by DEC and Ag and Markets in 2021. There's lots of different things. I'm just giving you a brief overview. So the inventory. So we have to think about 1990 levels because we need to go below it. And what I'm going to present are the 1990 to 2020 inventory report. And what you're looking at here is the state total emissions. So you can see that over the time course that most of these emissions naturally are from fossil fuel energy. So that's the big thing we all need to think about. How we can move away from fossil fuels and move towards renewables and make our homes and our workplaces more efficient. You can see in orange is the greenhouse gas accounting from agriculture. That is the work that Peter Woodbury and I have done for the state. And the green is the current estimates of forest carbon sequestration, right, in order to achieve that net neutrality. So that's below zero. This is where we need to get to, is 40% below the 1990 levels and 85% below the 1990 levels by 2050. But the good news is you can see there's a trend downward already, that we have become more efficient and we are using less energy in New York State. So without even trying, really, we have been reducing our emissions just by efficiency. Okay, so now I'm going to focus in on the orange section, right? This is the accounting for just agriculture in New York State to give you some context. One of the most important things to think about how agriculture is different than every other sector is that we have to think about 3 greenhouse gases because they have different potencies and personalities. And because they have different potencies, in order to make them all into the same equivalent units, the IPCC has come up with an estimate of relative potency. So carbon dioxide, CO2, always counts as 1. Methane, or CH4, is 84 times as potent as carbon dioxide. So when you have a pound of methane, you have to multiply it by 84 in order for it to become a CO2e, or CO2 equivalent. So when you see CO2, tons of CO2, it usually just means tons of CO2. When you see tons of CO2e, it could mean 1 ton of CO2e could mean 1/84th of a methane ton. That was terrible. I've never talked about it like this. So the point here is that methane and nitrous oxide are extremely potent greenhouse gases. And so small changes in methane and nitrous oxide can change the whole farm balance, right? So 1 pound of nitrous oxide is worth 264 pounds of CO2 being released. All right, so we got that out of the way. So here is a bar chart of the primary sources of emissions from agriculture in 2020. And what you can see is that methane accounts for almost 90% of our state's emissions. Nitrous oxide is 8%, and carbon dioxide is 3%. And when you think about that methane, most of it is coming from 61% of our total emissions are coming from enteric fermentation methane, the burps and farts of the cows. 29% is coming from methane from the manure storages. An additional 2% is coming from the manure management systems from nitrous oxide. 6% of total emissions is coming from nitrous oxide from the nitrogen that is applied to our soils. And then soil organic carbon is having a net release. Urea and lime are also sources of CO2. But the point here is that in New York State, which is admittedly a heavy dairy state, most of our emissions are from methane. Nationally, we have a zillion acres, I should know the number, of cropland. And so nationally, nitrous oxide is the predominant greenhouse gas from agriculture. But in a dairy intensive state, you really have to pay attention to the methane. Okay, in context. So what you see over here is that New York State in 2020 emitted 376 million metric tons of CO2 equivalents. And of that, most of it is from energy, but 6% is agriculture. So right there, we should just recognize that agriculture is a relatively small part of the problem. How we get to that, in our inventory, we established that's about 14 million metric tons from the enteric fermentation from the livestock, 6 million metric tons from manure management, 2 million metric tons from field nitrogen emissions, and less than a million metric ton from CO2 from lime, urea, and soil organic carbon. So that gives our total ag budget of 22.4 million metric tons of CO2 equivalents. Okay, so now let's look at, we're going to now look at these numbers here on the left over a time course for New York State. And what you can see is 1990 over here on the left and 2020 on the right. And you can see these different activities. So enteric fermentation obviously is the largest source of emissions. Manure storage in blue is the methane, and manure storage in the stripes is nitrous oxide. Green is the agricultural soil nitrous oxide, and then the last three up here represent the sources of carbon dioxide. One thing I will note is that there is only one exemption in New York State law, and that exemption for every sector, and that exemption is for livestock. And I believe that's just because animals are beings and we can't treat them like machines. So I believe that is going to be interpreted by DEC that this livestock enteric methane is exempted from achieving the goals of 40% and 85% by 2050. That being said, what we don't achieve from livestock enteric fermentation will have to make up with forestry or other products in order to compensate, because we have to be net neutral by 2050. Does everybody get that? I mean, it's kind of a nuanced point, but I wanted to let you know that this is probably going to be exempted, but I don't know until the end of this year. To note, unlike like across the state where we're reducing our emissions, you can see that ag emissions are trending upward. So we have some work to take care of, and that's where we come to manure storage. You can see that manure storage methane has increased since 1990 considerably. It's about a 275% increase in manure methane. And why is that? Because in the 1990s, we built out these water quality initiatives to increase liquid manure storage. which increases methane from anaerobic liquid storage of manure. So you have the same feed, the same microbes, sometimes even the same temperature if it's effluent from an anaerobic digester, and anaerobic conditions just like the inside of the cow rumen. It's just now in a pit outside of the cow, and it's producing large amounts of methane. So the point here is that this increase in methane has been driven by nutrient management plans that have been driving liquid manure storages, that have been driving increase in New York State greenhouse gas emissions. So just to show you this trend, you can see we have this group policy in New York State called the Ag Non-Point Build-Out of New Liquid Manure Storages. So you can see the trend going upward. And then you can see the New York State Annual Compliance Report for liquid storages, and you can see that trend also increasing. So this is basically why we have an increase in methane emissions in New York State. But there's a great solution, or at least a solution that gets us to 2050 until we think about what else we want to do with our manure more sustainably and holistically. And that is a manure cover and flare. So this is Table Rock Farm with their 2020 covered manure storage. You can't see the flare in this image, but this is basically just a liquid manure storage with a flexible membrane cover. And if we did this on about 500 farms, we could reduce our current emissions from manure storage by about 4 million metric tons. So that is significant within this emission area. And it's about 20% of our 1990 emissions. And so it gets us 20% of the way. And what's really great about it is because there is such a large amount, relatively large amount of methane in coming off of one little flare, it is, you get, and because methane is such a potent greenhouse gas, you can reduce CO2 at about $20 per metric ton just by covering and flaring. Okay, so what are the opportunities for the state? Well, there's a large mitigation opportunity, right? And there's a small number of stakeholders. There's about 500 farms we have to engage with in order to address this. It can reduce about 4 million metric tons per year, and it's a low cost, less than $20 per metric ton of CO2 equivalents. And if you remember in the beginning, the state considers anything under $130 per metric ton beneficial to future generations. There are existing programs through Climate Resilient Farming, which is an New York State Ag and Markets program, and NRCS. Many farms have already implemented it, so there's farmer-to-farmer relations. And what's super great is that you can have a meter to measure the flow, a temperature sensor to measure that the flare is functioning in order to report real, permanent, and verifiable mitigation, which is required under the law. So what are the opportunities for the farm? Well, there's two parts to this, right? You have to separate out the solids in order to be able to pump the liquids in and out easily and not have accumulation. So when you separate, you can then use your liquids for irrigation. You can use the separated solids for bedding. So it can reduce solids hauling. It can improve application timing because you've got two different forms. You've got the liquids and the solids with different concentrations, and you can decide where to haul and when. Potential to reduce bedding costs by using the solids for bedding, and the potential to sell the solids as value-added compost. The cover and flare component addition, after separation, it can reduce odor and improve community relations. It can reduce the rainwater hauling costs, so that's both the labor, the fuel, and the equipment costs to haul that rainwater, which then decreases field compaction and reduces impact on public roads from hauling that weight. You have increased storage capacity, so you can either have more cows or a longer storage period, and you can improve water quality because you have no extreme weather overflow events, so the rainwater is being excluded. You're not importing bedding nutrients, so you're reducing your overall farm nutrient load, and you can improve the timing of your nutrient applications. Plus, you are reducing a potent greenhouse gas with real, permanent, and verifiable flow meters and temperature sensors. So what are some of the barriers? Well, the state has a barrier, which is it has water quality initiatives that have driven greenhouse gases up, and every new liquid manure storage we build on a farm increases our state emissions. And 2 years ago, I don't know what last year's were, but 2 years ago, they had 70 applications for new liquid manure storages. So you can imagine, you know, the emissions are just going to keep coming up. Another barrier is people want to just, why do you just burn the methane and not get an energy value? Well, there's extremely high costs and maintenance for an anaerobic digester system. Right now, there's a lot of projects in Western New York that are being driven by obscene energy rates from a California incentive. In addition to the fact that's for compressed natural gas to be piped from New York State to California as renewable natural gas, there are also several anaerobic digesters in the state that are producing electricity, but electricity costs prices are not great to support them. So some of them are closing down, some of them continue. The amount of methane that is coming off of a manure storage is relatively small, so you're not actually getting that much energy. And an anaerobic digester is going to intentionally produce methane, so you're not actually going to get the methane destruction credit for the intentional production of methane. So there's a lot of nuance there. There are a lack of engineers, ag engineers generally. There is a lack of installers. And then there is some need for coordination between state and federal funding to assist farmers in cost share, because when you start adding up all the pieces, it gets kind of expensive. And I would love to have a discussion, if we could, about NRCS scenarios and systems in Pennsylvania that can help advocate for covers and flares. There are some barriers to the farmer, of course. There's upfront costs to the farmer. It may require an engineering to retrofit. There are many pieces to sequence, right? You need separation. You need a solids roof. You need to have a good manager to manage if you're going to use the solids bedding to displace your other imported bedding. There are certain things you need to think about for the cover and flare, which we will talk about in a minute. Milk pricing and farm ability to participate in cost share is always, can be a barrier, which is why we need to work on state and federal sharing. Separated solids requires real management for the herd, right? You can have slipping issues and cull count increase, and you can have milk count problems, etc. You need technical assistance. And if the farm is using sand bedding, it requires additional work to transition to separated solids bedding. So there are active projects in the state. There are 10 projects across New York State on the left. And then there are several opportunities to help farms install cover and flare, such as the NRCS practice standards. In New York State, we have something called the Climate Resilient Farming. That's funded by a real estate tax, and that supports cover and flare. New York State Ag Non-Point, which is about a water quality initiative that's been building out all of these storages. It does allow for the new storages to be built with covers and flares, or to be designed to easily retrofit for covers. But still, so far, there's very few that are being installed with new storages being installed with covers. New York State also won a Climate Smart Commodities USDA grant, which will support $10 million of farm activities, which includes covers and flares. And in 2022, New York State, on our ballot, we voted for the Bond Act, which is a $4 billion act for all kinds of infrastructure projects across the state. We don't know how it's going to be allocated just yet, but cover and flare would be a good option. To give you a sense of how much it costs under the climate resilient farming, so under this climate resilient farming, round 6, we just finished round 7. I don't know if it's public yet, but in round 6, everything leading up from rounds 1 to 6, manure cover and flare cost about $17 per metric ton of CO2 equivalents addressed. But you can see the water management systems were around $3,000 and the healthy soil initiatives were $500. That doesn't mean we don't do things because they're important for water or soil health or whatever. It just means that in terms of greenhouse gas mitigation, manure cover and flare is by far one of the cheaper opportunities to address. Okay, some considerations for cover and flare. Thinking only about the liquids portion on the left-hand side and the solids portion on the right-hand side. You need to separate the solids so that the liquids can be pumped in and out easily, and you don't have to remove the cover so that you don't have leaks. And it doesn't need agitation. There is the potential to build out irrigation systems. I'll show you some images of one farm who's struggling with drought and installed an irrigation system next to one of their cover and flare systems to address their drought. The cover increases the storage capacity by reducing precipitation collection. It decreases extreme weather SPDES violations. It increases the concentration of nutrients so that you can be more efficient in your application. It requires an emergency valve to release the gas pressure over the liquids portion, and the cover reduces odor and reduces hauling, both time, energy, and equipment. The solids portions, farms are using the solids to eliminate imported costs and nutrients from purchased bedding. The recycled solids bedding reduces the total volume. That reduces the transportation on public roads, reduces hours and fuels and tractor passes on the field, and increases choice when and where the smaller volume is actually applied to the land. A few farms are selling the solids for high value public compost sales, but if used for bedding, it does require increased management for ensuring herd health. So some collection pits. You need to have this collection pit. This is from Ken Van Slyke, who is a separators dealer out in Western New York. So probably close to some of your farms in Pennsylvania if you were interested. I'm not trying to pitch for him. I'm just, these are his slides. So there are these collection pits. But then you need a screw press or something to separate out the liquids from the solids. There are many brands, but you need to remove the fiber, and it's scalable for all size dairies. And you can get a consistent dryness of the separated fiber. Now, when you have the separated fiber, or those solids, you need to make sure that they're composting. You can see in the left image here, the steam coming off of Dale Stein's farm, also in Western New York, if anybody wants to go visit. I'm sure he'd be happy. He's the chair of the Soil Water Conservation Committee, overseeing some of these funding opportunities as a farmer in the state. But you need to get the temperature up to 160 degrees in order to kill the microbes. Some farms are not composting. They're using green manure for bedding. I don't know much about that. And other farms are selling the bagged compost to a neighboring town. Granted, that particular farm is very close to a very wealthy academic town where the bag compost has great citizen purchase value. Here on the right is Dale Stein's irrigation system that he connected to his liquid storage with cover and flare. And he has some issues with these, just a few spaces of drought in the summer, and this is the system that he installed. This is a storage just before you're going to put on the cover. This is just a standard storage. I'm sure you're all familiar with it. What you do is whether or not it has a line storage, you can build these trenches and fill in the trenches with concrete. This is from Jason Taylor from the South Carolina Environmental Fabrics, who is one of the few installers that actually comes to New York consistently. These are some images from Jess Skinner. There's a 20-minute video I recommend all of you to watch where she goes through all of the different considerations on all of the different farms she's worked with to think about where you have your rainwater pump discharge, where the flare is located, where the loadout manhole is located. This is just one example from her talk, and I'll share that later. Because you have this impermeable membrane on the top, the water collects, so you need to have a pump to pump that water off. It's clean water, and so you can decide what you're going to do with it, but that is a consideration. On the left is an example of a flare with a windshield. Often the flares can burn out, and so some people are putting in from wind, or be blown out, I guess is the correct way of saying it. So some are putting in windshields, others are putting electric clickers so that when temperature goes down, it recognizes that the flare is not working and there's an automated clicker to restart it. And on the right-hand side, you have to have an emergency vent. You can see here that gas is starting to build up. So if something should fail, you need to have an emergency vent because you don't want to have a terrible event. These all require some kind of energy. This is a different flare system, but it's outfitted with a solar panel in order to help things go along. Other people have a battery pack out there, and then other people have had an electricity line that was close by that they could use. Notably, some of the opportunities in New York State for funding cover and flare can allow power lines to be drawn and three-phase power lines, which is a really important attribute for building out renewable energy on farm. So that can be packaged in New York State with existing CRF proposals. And here's what I love the most is that you can have these sensors that measure the flow that is coming through, and then you have a flare temperature sensor, not shown, where it shows that the amount of gas flowing through is burning hot, and so that's how you know that it has been destroyed. And so these are very simple ways of showing real, permanent, measurable, and verifiable destruction of methane. So it's kind of a poster child for a real, permanent, measurable, and verifiable, which I'm not going to talk to you about today, but I'm happy to come back if you want. So a fast checklist to determine if a farm is well suited. Do they already have an earthen storage with or without a liner? Do they already have a separator, or do they want a manure separator? Are they in need of irrigating liquids, or are they interested in using the solids for bedding or to sell as compost? Do they have neighbor odor issues? Do they have overflow events, or are they maxing out current storage capacity? Do they want to grow their farm size? They don't have sand bedding, or they have sand bedding and are interested in moving to manure solids bedding. They need to reduce their solids management strategies or increase their concentration of the nutrients, or they have drought issues. If they have sand bedding and they're not interested in changing away from sand bedding, it's probably not a good idea to pursue cover and flare. If their current storage unit is crowded by other infrastructure, it is difficult to layer on this large cover if you don't have enough space. And you also have to think about where your flare and your emergency valve goes. So if it's crowded by other infrastructure, it might not be a good site for cover and flare. And if they have no interest in manure separation for any other improved value or improved nutrient management goal. Just in summary, the CLCPA, or the Climate Act, is an umbrella policy for all sectors. The goal is a 40% reduction by 2030 in New York State, and the social cost of carbon is $137 per metric ton of CO2 equivalents. The cover and flare with separator, which is required, can address about 20% of the ag goal to reduce emissions by 2050, and is currently being installed at less than $20 per metric ton of CO2 equivalent. So it is a smart policy for New York State to pursue. These are the 20-minute webinar on the design considerations by an engineer, Jess Skinner, here in New York. I highly recommend it. It's 20 minutes, and you will learn a ton from her, as well as a 10-minute discussion by Dale Stein about his cover and flare, his solids bedding, and his irrigated liquids. He also has said he's had increased milk yields from his cows on separated solids bedding because they have such a plumb stack, that the herd is super happy, but you can hear that from him yourself. Just so you know, the climate smart commodities that Cornell, SUNY USF, Syracuse University, New York State Department of Ag and Markets, and New York State Department of Environmental Conservation, we got this $60 million grant. And within that grant, there are 2 methane detection projects by ProDairy and Bob Howarth. This is what you're looking at here, is ProDairy walking around a manure storage in New York State in early December when it's 32 degrees out, and you can see that there is a large plume when they're walking around, even when it's 32 degrees out. They'll have more data soon, but it would be an interesting group to invite if you're interested. So who's problem solving with us? Well, just after this meeting, I'm attending a meeting in Western New York with Soil and Water Conservation District agents and the DEC about the lack of engineers in Western New York to help us design and implement. These are not heavy design projects, but they still need engineers to plan them and put them out. So if any of you are interested in joining us on how we can expand this or make this more viable, let us know. We are desperate for you engineers. A group of us in Northern New York are working on how to help farms transition away from sand bedding. So if someone is interested in that. And then again, there's these different research projects looking at methane detection and evaluation from farms. Of course, you don't have to have a liquid manure storage, and it might be great not to have a liquid manure storage. In fact, daily spread would be a great way to get rid of a lot of greenhouse gases, but we're not going to go that way. So we need to think about some key considerations if you want to design something different. So more aerobic systems means less methane, though notably more aerobic systems means more nitrous oxide, which is 300 times as potent as CO2. So that's a complication there. Cooler temperatures means less methane, but you could see at 32 degrees, the storage was still producing methane. Less time in the storage means less methane. So you could apply more frequently, but you can't forget about your nitrous oxide emissions when you're thinking about the whole farm plan. And notably, the liquid manure holds about 75% of the cow nitrogen. And because it is highly anaerobic, it inhibits the nitrous oxide production. However, that being said, you have Peter Vanderstappen's talk later on manure solids drying case study, which I'm sorry I'm going to miss, Peter. I really want to hear it. Or you can increase your field applications so you only have your liquid storage, but you got to think about things like building out irrigation infrastructure, etc. But this is why we are targeting liquid manure storage, because there's almost a 300% increase in emissions since 1990. But there are other mitigation strategies for farms that we should all be thinking about. How to improve woodlands for long-lived wood products or silvopasture or agroforestry. How to activate idle lands. We have 2 to 4 million acres that are not active in New York State. So how could we grow forests or install solar, increase forages, or increase silvopasture systems? How to help farms move towards electrification and infrastructure. So you need to build a new manure storage solids barn. Can you make it south facing with the right declination in order for it to easily receive solar later? Can you think about how to bring in three-phase power to expand the farm's capacity? Plan to phase out fossil-powered equipment where it's savvy, it's not always appropriate, how to increase farm efficiencies, or build with long-lived timber products, though I see, which you also learned about with concrete earlier, but I wasn't able to hear all of it. There's also things like hempcrete, which is concrete made with hemp in order to, I don't know if you talked about that, but and then feed and nitrogen use efficiency. Both of these are cost savings to farm, and they reduce greenhouse gases. Thank you. And questions? This is how we were funded. And I will refrain from those further slides. Okay, questions?
Thank you very much. We appreciate that, and I think we will have some questions here coming in. One question I had, well, I wanted to make a point first. I had the opportunity to visit a couple of farms just maybe 2 weeks ago. One farm had a cover, and in Pennsylvania, Act 38 for CAFOs requires 24 inches of freeboard, but with a cover, they only require 6 inches. So a big draw for this producer to do a cover at his own cost, it was his own financing there, was to increase his storage capacity by adding the cover, and not only did it reduce the rainwater that he would be dealing with, but it also allowed him to store up into a higher freeboard level, so, or had required less freeboard, which I thought was a good point. Now, this same producer, though, like I said, did the cover on his own, and he had put in the very cheapest flare possible, and that flare had disintegrated at this point and was basically just releasing methane into the atmosphere. So probably a negative situation that we have now created there. This same producer seems to have found an opportunity with the Hershey Foods, and they are piloting some work to reduce greenhouse gases, and part of their efforts are going to be maybe installing better flare systems for producers with covers, and he's going to be the first one, it sounds like. But just curious if you're hearing those kinds of situations, the challenges with ongoing maintenance and repairs that go along with covers. So that's a long question, but that's the root of it.
There are all kinds of ongoing maintenance and repairs. I'm going to stop share first. Hold on. I should have done that. Stop sharing. Did I stop sharing, or are you still seeing my crazy screen?
I still see. Oh, it stopped. It stopped.
Okay. There are definitely problems. So so there's a condensation pipe, right? And if enough water builds up in the plastic PVC condensation pipe and it freezes and then it cracks the pipe, right? There are issues with the water accumulating in the top and the pump not working, right? There are all kinds of issues, but they're all manageable issues. Though I guess there's been a farm that didn't have a fence around it, and a deer jumped in the middle and punctured it, right? You can anneal it back, but you still have to wait for the company to come and anneal it, because there's not a lot of companies. It can take time. There's all kinds of ways in which the flares are not working. But in the scheme of things, the flare is a tiny, tiny cost, and it has a huge greenhouse gas benefit. And so all I would caution everyone is that if you spent all of your money installing a storage and a cover, and it only costs $75,000 to get a good, and I say only, I mean, I understand that is not inexpensive, but you have to be really savvy if you're going to sell those carbon credits, because you have done a lot of work with the separator, the storage, the cover. You have done a lot of work to just sow those credits away. And the same thing for the state. The state has done a lot of work, perhaps, in helping these things to just sell it away to a third party, which is a whole accounting thing that we could discuss in a whole nother meeting. But I just want to advocate for farms to advocate for themselves. if they're going to sell their carbon credits, because these methane destruction credits are some of the best credits out there, because they're real, permanent, and verifiable. And so I don't know. Yes, there are problems with cover and flare. It requires management like anything else, but it can also have all of these other kinds of benefits that we've already talked about. So it is
that slides real well into our next question, if you don't mind. So have farms been able to sell their carbon credits on the national market through a broker? Thoughts on that? Are they selling in other ways? And for the producer I mentioned, in his mind, he didn't see a financial benefit to maintaining that flare. And if he had a financial benefit, he would, or even if it was a net zero benefit, I think he would have. And that's why he was waiting on Hershey Foods at this point.
Okay. So in New York State, the compressed natural gas market is being driven by incentives from California, and it's something crazy like $6 per therm, or I can't remember. I have my units all wrong there, but it's crazy. It's like 6 times what a normal amount of natural gas. So in that case, people are putting in anaerobic digesters. They probably have a cover and flare in order to capture even more of the gas, because it's incentivized to capture all of the methane. And then they have a cleaner system, which cleans out all of those corrosives. That's probably why this farm in Pennsylvania corroded out so quickly, right? You have to clean out all of the corrosives that are in there, or, in order for it to go into the national gas lines, so that you're not putting in corrosive gas into national infrastructure, right? So that is a huge incentive. In 2007 to 2009, there was a huge amount of carbon credits being sold by a private group. It all kind of went defunct. And so I don't know of anybody who is selling manure methane credits in New York State. That being said, we also have an accounting issue here. And I don't know how I'm going to do this visually to help you all sort of see this, but say you have an airline company in Pennsylvania, right? And they're putting out 100 metric tons of CO2. And you have a dairy farm over here that's putting out 100 metric tons of CO2 equivalents. Now that dairy farm takes care of all of those emissions with a cover and flare, gets down to 0, right? Goes down. Now, this airline industry can buy those credits from the farmer. And now they can produce, right? They're not regulated. And now they can emit twice as much, and we get no net gain. And so there's a whole accounting debacle with selling carbon credits. That isn't to say that we can't roll the monopoly dice and go around the board and make policies, but we have to be careful about selling carbon credits, because if it just legitimates the production of more fossil fuel emissions, then we're not getting anywhere, and it can be sort of an accounting shell game. So I just want us to be sensitive to the fact that carbon credits are kind of the Wild West out there, and may not, while it may bring in a certain amount of money to farms, in my opinion, it's generally too small for the farms, for it to be worthy to the farms. And it's problematic from a whole farm, a whole state, a whole nation, a whole country accounting perspective.
But very good. Thanks for that response. Next question. Does carbon sequestration by crops help balance greenhouse gas emissions from dairy farms?
So I want to recommend you all Google search FAST GHG. I'll try to put it in the chat. It is a tool created by my colleague Peter and some other colleagues here at Cornell for net greenhouse gas accounting from soil health practices, whether it's cover crops or tillage, or legumes, right? All of these different things with different types of cropping systems. And what you will find is that the relative amount of greenhouse gas mitigation from soil systems, it is very small, very small. To me, it has been way overhyped and is also problematic because soil carbon sequestration is also not permanent, right? Soil carbon can stay 1 to 30 years in the soil versus tree carbon, right, can be 200 years in the forest and then 200 years in the building that tree product went into. So that's 400 years of carbon sequestration, which is far more permanent. So I would say soil health is not going to help a dairy farm at all. And I would also say nitrogen use efficiency would be the #1 thing that a crop farm could work on, in addition with thinking about how to build more forest infrastructure on their property to sequester carbon in the forest system.
Very good, thanks. Next question. For the required reduction in ag emissions in New York, where does the burden lie? Is it with the state agency or does it fall on individual farms? Who's responsible there?
I think this is what DEC is going to figure out by the end of 2024. I don't know. If I were to read the tea leaves, I would say that probably what's going to happen is the state is going to fund the increased funding for the climate resilient farming program through different kinds of tax revenues in order to help farms comply. Just because that's what they've done for water quality. But to know, all sectors are being regulated. So for example, I live in an apartment building and my apartment has a B grade right now for energy efficiency. In 2025, some apartments are going to have to pay the first fine if they're a D or an F. In 2030, my building will have its first fine of $1,000. Now, there are 50 units in this building, so $1,000 a year is not a problem. But by 2035, if we haven't reduced our greenhouse gases in our building significantly, we will have a $60,000 a year fine on our building. And all of these fines, at least for New York City apartment buildings, are trying to incentivize to, instead of paying the fine, work on making our building more energy efficient. And there's lots of ways that have been shown to make our building more energy efficient, but it requires some planning. And I was on my co-op board, and co-op boards don't really want to plan, that far into the future, because it's nobody really wants to plan that far into the future. But what these goals are doing is it's requiring us all to think about how to plan for the future, which is why if you're engineering a new roof system, please think about making it orient to the south with the right declination for solar in that area. So if the farm wants to put in solar later, it isn't some massive retrofit and you're maximizing solar capacity. Or it means if you're thinking about bringing a cover and flare in and a subsidy allows you to bring in 3-phase power, please bring in the 3-phase power so that that farm can be a net producer in the future. Or if your farm has X units of equipment and when a piece of equipment is going to phase out, think about which pieces of equipment might be smart to electrify, so that when you get your solar panels and your 3-phase power in your sequence over the next 30 years, you have a way of charging your equipment with electricity you're producing on farm. So we all need to start helping farms think about long-term plans in order to bring them in line with everything else. Because as soon as we start reducing emissions from the energy sector, right, the amount or the proportion that is coming from agriculture is going to increase unless we also contract the emissions from agriculture.
Very good. Another question. Is solid separation required for a cover to be on a liquid storage? With the carnival tent style covers over concrete round tanks, can agitation be completed and allow no solid separation? Would this style system reduce the greenhouse gas benefit? Would this still produce enough methane to burn a flare? A couple questions there.
Okay, so almost every storage unit will produce enough methane in the summer months. Like you watch the peak, it goes like this, right? This is January, this is July, August, and this is December, right? So almost every storage will produce methane in significant amounts in summer months. Jess from Jess Engineering, she has not done a concrete storage cover. I have seen in Europe those sort of like, it's almost like you have this tie down system for this carnival tent that you're speaking of. And they're doing it. I have not seen one in the Northeast, so I don't know the answer to that. But what is lovely about your ideation there is that while there are methane emissions in the winter, they are usually too small in order to run a flare. So I could see how you could have that cover on in the summer and even let it be, I mean, in the winter, and even let it be leaky so that you didn't have to worry about any kind of buildup. Tightening it down. Yeah, and I don't know how the flare works with those systems. I don't know the answer to that question, but I think there is a reasonable thought process there that should and could be explored.
Yep. Very good. Very good. Another question. This is back to me. I jotted this question down earlier in your presentation, and then you kind of alluded to something in a later slide. But last year at our workshop, we had a presentation on a continuous aeration system. There's a series of piping and manifolds, and the air rotates around that system to keep that manure in an aerobic environment. So we recognize that the methane issue is improved, but the nitrous oxide would go up in that aerobic environment. So what's the net? I know you said to beware of the nitrous oxide, but are we actually creating a negative situation with that, or is there a net benefit to keeping our manure storages aerobic?
There is no analysis that I know that isn't anything other than a penciled calculate. You know, I don't even know of a penciled calculation for that. Most people are not thinking about net greenhouse gases at all. And so that's point number one. Point number two, in that scenario, you have to think about pumping water, which is energy intensive. So you have to add that into your calculation. Because nitrous oxide is 300 times as potent as CO2, then it quickly becomes a problem. And the next issue is that the liquid portion of the manure takes the majority of the nitrogen. And now you're increasing that nitrogen loss, which means you're decreasing your nitrogen for your field application, and you need to think about. So what's so great about a liquid manure storage is because it is so anaerobic that it does a fairly decent job of retaining that nitrogen for spring application, just when you need it. So you also need to consider if you're going to have to increase your purchase of synthetic nitrogen because of that loss. So I don't know. My gut says aeration is a lot of work with not much benefit. That's in terms of greenhouse gases. But that's my gut. I have nothing to point you to. We don't know, and we need studies, and we need studies that measure both the methane and nitrous oxide at the same time, which is why these two projects, well, they're not measuring methane and nitrous oxide. They're just trying to get a handle on the methane from current manure storages. But I can't answer that question. It's a great question.
Yeah, thank you. Appreciate that. Well, I've no other questions in the chat. I've got one more for you, though. So a cover and flare system is a great option for some producers in Pennsylvania and other states, but we also have a lot of smaller producers who are never going to do a separator, and it's just probably not the right fit. So do you have favorite alternatives maybe? Is there something with feed management or a push to store manure minimize storage time so that you're spreading during the summer months instead of storing it, things like that. What good alternatives should we be talking about with producers?
Naturally, improved feed efficiency is going to increase milk production and reduce the amount of manure that is excreted. So feed efficiency is definitely a good option. For smaller farms, reducing the nitrogen in the feed would probably be a good idea, as long as you're not losing your protein content, or depending on what the farm's milk profile goals are. Definitely, if there's a way in which you could think about moving away from purchased corn and soy and moving toward more forage systems that you harvest more frequently, so that it's younger forages with higher nutrient content, so that you could then daily spread or not daily spread. You could spread after cuttings, things like, so that you're reducing your storage time. Yeah, anything you can do to reduce the storage time in the hot summer months is a good idea. That's a simple fact.
All right. Thanks. Well, we packed a lot into your hour. Greatly appreciate it. Thanks for answering all those questions. Your one slide noted about having conversations regarding scenarios. We welcome those conversations, and I hope we can continue these talks. And I may even have an opportunity to talk covers and flares in front of a few national discipline leads if you're open to it this summer. So we're hoping you can maybe help participate in some activities we have going on around Harrisburg. Sounds good. We'll be in touch on that then.
Can I just request that if there's any builders out there who you all know that are putting in line storages, to consider putting their hat in the game, or however that phrase goes, for building out cover systems in New York State, and then also perhaps in Pennsylvania. There's a lack of installers, and there's a real need. So if someone's already working with this flexible membrane for the liner, it would be a great opportunity, business opportunity, at least the next 5 years, in my opinion, to come to New York and start installing the covers and flare systems. And then if there are any engineers in Pennsylvania that want to help us out, we need to have some kind of engineer system to help farms do it. It's not as complicated as an anaerobic digester system, but nonetheless, there's got to be a way of streamlining this, or even helping a farm think about moving towards an anaerobic digester, but this is a stepping stone in that direction. So I just want to say that there's real demand and real need, and if anybody wants to reach out to me, I would love to brainstorm on how we can activate your skills to help these projects go forward.
Thanks a lot. I think those same challenges ring true for Pennsylvania and other states too, having the contractors to build. Hey, there's tons of funding support right now for conservation. Having the professionals to design it, to engineer it, and then the contractors to build it are real challenges that we're certainly seeing here too. And I wish there was an easy fix, but definitely open to conversations on that out of the state office here too, Jenny. So thanks a lot. Greatly appreciate it. And with that all, I believe we are due for a 10-minute break. So check your emails, get some coffee, and we'll be back at 10:40 with Brent Leatherman. So thank you very much. All right, 10 minutes goes quick. I have 10:40 on my clock here. So do we have Brent Leatherman on the call now? Looks like he's coming up. Okay, I'm gonna quickly introduce Brent. Brent is a Penn State graduate with a degree in ag engineering. Think it's now called something else, but ag engineering from Penn State. And he began his career in the wood engineering and design industry and then expanded into structural design of steel truss supported tension fabric buildings. He's a member of the American Society of Civil Engineers, the American Institute of Steel Construction, and the National Frame Building Association. And he served on their technical and research committee. And he's now the principal engineer and owner of Ridgeline Structural Systems, located in Couts, Indiana, and that was established in 2016 and provides structural design and drafting services throughout the United States and Canada. And side note, he resides in Indiana with his wife, Kim, and has 2 married daughters and 1 grandkid. So, Brent, with that, we'll hand it over to you. Looking forward to your presentation today. Thanks a lot. And you might be muted if you're talking. I'm not hearing you. Let's see. Yeah, still not hearing you, Brent. Looks like you're not muted, so I'm not sure. Still no sound coming in. Let's see. May have lost Brent Leatherman. Maybe you want to try jumping that. Oh, I hear something there, Brent.
Am I coming through now?
You are. Yes, I hear you well.
Okay, yeah, so sorry about the mix-up there.
No
So
problem.
thank you, Tim, for the introduction. I really appreciate the opportunity to talk with you today about steel-supported tension fabric buildings. Is my presentation coming through on the slides?
No, it's when we had some audio issues that you stopped sharing there at one point. So if you want to share your slides again, that would be great. And looks like I see it. You're good to go.
Okay, excellent. Very, very good. Thank you very much. And so my talk today is titled Alternatives to Timber Roofs, Steel-Supported Tension Fabric Buildings. And by way of working definition, I would like to give you something to kind of put your hands around. What we're saying this is a membrane structure supported by a steel frame. The structure consists of a membrane tension between primary rigid frames or trusses, secondary bracing members such as purlins and cables, and then the anchorage, which really is the foundation. We tried to pack a lot of photos into the slides because that really gives the best representation of what these buildings are and how they can be used. As by way of a topics outline, I'll be summarizing the benefits of this building style and this building type. We'll be doing that right up front, and then those themes will weave in and out of the talk as we go forward. I'll be doing 3 comparisons here of steel framing versus wood framing, the tension fabric roof versus a more traditional steel roof panel, and then a gable roof building versus a hoop style, and offering some comparisons of those things. And we'll talk about technical specifications and a few thoughts about the EQIP program. And so by way of summary, we'll be talking about a gable roof style, which allows for overhangs a true peak and gives a traditional look to these buildings. We'll talk about hot dip galvanized steel and how it performs and how it can withstand corrosive environments. We're talking a lot about fabric roof. It's a unique material with high strength and long life, and natural light that comes through, and we'll be highlighting that a lot here in this talk. I have to chuckle in our next point, the high, wide, and open. Many years ago, or really toward the beginning of my career, I think, I heard a talk by Pete Vanderstappen, and he talked about ventilation, and he was talking about this high, wide, open design. And I never forgot that. I always kind of kept that with me through the years and through my design work. And as I look at these buildings and even the photos that are in this presentation, that's really what comes to mind to me, is that high, wide, and open design there, along with the natural light that we'll be talking a lot about. These buildings can be fitted with wood girts and durable wall coverings, which is beneficial for quality and long life. We'll be talking a lot about ventilation and touching more on that, the efficient natural ventilation. Livestock health and comfort. What we're talking about here is, what is the bottom line for the producer? What is good for the farmer, for the cattleman, for whoever is working in these buildings day in and day out and deriving their livelihood. And what we're seeing is better production due to the ventilation and the natural light. These buildings can easily accommodate overhangs and gutters. Custom engineering and fabrication is available, to where we're really saying that these buildings can be built to various sizes and needs, depending on the producer's needs and desires. Quick installation, the frame and roof can be installed in days. There are foundation options available. And these buildings have salvage value at the end of their useful life. And so with the first comparison that I'd like to do here, just talking about steel framing versus wood framing. In a steel frame or a steel truss, the top cord and bottom cord are connected to a steel column, and it really creates a strong truss to column connection, a strong moment resisting joint there. And knee braces in wood buildings create a similar joint, but they restrict clearance, and they're really not suitable for larger buildings. And I know that within the state of Pennsylvania and within other states, including Indiana and Illinois and some of the states around here where I am, you'll see a lot of wood frame buildings for roofs and covers in NRCS projects. And I believe in the state of Pennsylvania, there is a design guide for 40 and 50 and 60-foot wood buildings. And they work fine. They work well in their application. But as we start to look at some of the differences between steel framing and wood framing, what I see from the engineering side is this strong moment resisting joint that can be created with bolted or welded connections. The steel material has a higher strength and stiffness than wood. This also allows it to go higher and wider than we would see in typical wood designs. One of the similarities, I guess, between the systems here that we're talking about is both are non-diaphragm. And so for the structural frame to have inherent strength is important. It's not relying on the roof steel or enclosed walls or anything like that. Wood is a versatile product, and it's easy to work with. A lot of contractors out there are familiar with it. And so I'm raising the question, is it possible to actually create a hybrid building design which combines the strength of steel with the versatility of wood. Hot dip galvanized steel will hold up in challenging environments. And so we see that time and time again, whether it's livestock or dairy, or even in some of the other corrosive environments where this system is utilized, the benefit of the hot dip galvanized steel is evident. We're able to accommodate fans, catwalks, or other loads very easily with this system. Probably the best or the most important benefit of the steel framing is simply the large clear spans, the cathedral design that can be had and can be incorporated into a steel truss. This creates a simple design with clean sight lines, no obstruction to airflow, versus the photo at the bottom right of the screen, where we have a wood truss system, the flat bottom cord trusses or knee braces and truss bracing that really adds up to congestion and restricted airflow. Steel columns are typically kept above grade, as opposed to wood columns, which in some instances are embedded. We see just for the long-term benefit of the building and for the producer, we like the above grade foundation. Some other notes about steel building foundations: they can be designed, of course, according to the PA 313 requirements. They can incorporate ramps, slopes, pits if required. Watertight seal designs can be easily incorporated into the steel building foundation. And there are numerous foundation options that we have available to us that we can use, depending on the application, depending on the liquid tightness that is required for the particular application. In some cases, we'll use a round bell pier to grade, and this is a round augured caisson or pier, if you will, with a bell on the bottom that increases bearing capacity and increases uplift resistance for that foundation. We can tie it into the floor with a hairpin rebar and bring the column down on top of that pier system. The round pier above grade can be utilized, square pier to grade, or a more traditional stem wall above grade, which can be used for bedded pack applications. It could be a version of this used in a deep pit foundation as well. And lastly, with a steel frame versus wood frame comparison, we see this salvage value. It's really something that has come up in several instances where not only is there value for the building for scrap metal at the end of its useful life, but these buildings can be moved. And if you think about a hot dip galvanized frame like this that's moved from one location and set on a new foundation at another location, new fabric can easily be put on the building, and it's in nearly like new condition. So for a comparison between the tension fabric roofing and steel roof panels, the major effect that we're seeing out there, not only live on farms, but also warnings on plans and things, is the corrosive effects on the steel roofing. This picture on the left is a building I visited a couple of years ago in Manning, Iowa. It's a 132 by 200 steel building, only 10 years old. And the photo on the right indicates the red circles indicate pinholes that have developed in those steel roof panels just from the interior conditions, the ammonia or what have you. And there, in talking with the producer, there is no warranty on the roofing panels for this project. Similarly, on a note on plans that were put out by a national supplier of wood buildings that came across my desk recently, this was a note that was on the cover sheet of the plans. It says, important caution. The environment in which the roof steel is being used is a corrosive environment. There is no warranty on either the paint system or the roof steel due to this corrosive environment. And so we're seeing a situation out there where roof panels are being put on livestock housing and they're not lasting the length of time that they really need to, and they're not covered by a warranty when they do fail. So what is our response to that? We're saying that the fabric roof is a long-lasting alternative, and it comes with a 20-year prorated warranty from most vendors. The fabric can last 20 to 25 years or more if installed correctly. And there are a few things on this particular slide that I would like to highlight that speak to what does it mean to be installed correctly? What are some of the things that can be done with the fabric to enhance the life of the fabric? And so we're saying that the fabric is segmented. It's installed in sections and kept in a flat plane. This means that the fabric that goes on this building that I'm showing, this building style that I'm talking about, is not a large piece that drapes over multiple frames. It actually connects to the top chord of each truss by way of a formed aluminum channel, which is called a Keter strip. And that's what fastens the fabric panel to each truss. The width of the segment of the panel is equal to the spacing of the trusses. And so the Keter strip is attached to each truss top chord, and the fabric section is slid into that. The fabric is clamped at the ridge, as shown in the picture in the middle. And this is where the fabric is terminated. It doesn't come over top of the ridge. There's an opening that's left for ventilation, and it keeps the fabric in a flat plane that doesn't wrap or pull or bend over any curves or anything within the system. At the bottom of the roof panel is a wrap pipe that tightens the fabric down in the up and down direction. Over on the right-hand side picture, the vertical strips in that roof line, those are the Keter strips as they would be installed. And so each section of fabric is pulled and installed into those Keter strips. And it leaves the fabric panels all tied down on all four sides. And this means that there's no rub, wear, or abrasion, and that's really the key that leads to long life for the fabric. So the corrosive resistance nature of the roof panels, of the fabric panels, is one thing, but the natural light and natural ventilation is really the biggest benefit that we see with the fabric roof and the benefits that it can bring to the building. We're talking about bright, natural, shadowless lighting, and this results in better production from livestock. It's really a point that I can't overemphasize or stress enough, where we're talking about milk production, we're talking about feed efficiency or rate of gain, if this is a cattle operation. And these are the things that we're trying to do, not only to accomplish the requirements of the NRCS practice standards, but also to go further than that and actually produce something or provide something that helps the producer themselves. We're seeing a reduced need for mechanical ventilation due to natural convection currents that are stirred up inside the building from the natural light that does come through. And since most of the sun's wavelength is prevented from coming through, it actually, the roof fabric actually has the effect of preventing the interior of the building from overheating. For the comparison between a gable roof style and a hoop style, or a gable roof and the hoop style building, we're seeing the gable roof being a traditional look that can be outfitted with steel siding, trim, and overhangs. It would have a true peak that can be outfitted with various ridge treatments as well. It allows for a gutter and downspout system. It allows for building additions. And as mentioned before, it lends itself to sturdy and durable wall finishes. Ventilation is probably the most stark comparison, or the most stark difference between the two styles. With the high open sidewalls and a high ventilated peak, these buildings with the gabled roof shape can have superior air volume and air exchange within the building. And because of the straight roof line, as opposed to a curved roof line, we don't see dead air pockets within that stratum, within that profile. This leads to better condensation control and better ventilation overall. There are numerous options for the ventilated ridge with this style, mainly due to the fact that it has a true peak. We can do the overshot ridge on the left. We can do chimneys or cupolas as shown in the middle photo there, or a continuous chimney. You might call it upstands, something like that, but that can also be provided. It should be noted as well that with the chimney, the cupola option there, or the upstands, it's always going to be a priority with the building styles the building style that I'm proposing here and designing, that we always want to have steel support structure underneath those roof treatments, as opposed to just supporting them on the fabric itself. We have the capability of overhangs and gutter systems with this building, extended overhangs, cantilever overhangs that might be created with a truss, as on the back side of the photo in the middle. This can be a cantilevering truss extending out 20 feet or so to provide that extended overhang if needed. The gutter system is available for the fabric roof building. Fabric longevity and installation in comparing with this gable roof style and a hoop style building. The fabric is going to be installed in strips for easy installation and also for the no rub points and not draping that piece of fabric over multiple frames. The fabric is fastened both sides, top and bottom, and it has no wear or rub points as we would see on the hoop style building. By way of technical specifications, I'd like to take a few minutes here just to talk about design criteria, building geometry, and some of the general things that we're seeing, codes and things, and then I'll finish with more of a specific design example looking at a particular building. And so for structural codes and standards, the 2018 IBC, the structural provisions, we're typically following that. In other states, it may be a different version of IBC, but we're going to be doing those load calculations according to ASCE 7. The ASC 55 is a tensile membrane structures document. And then the others there, steel, wood, and concrete, are the typical codes that would be used no matter what building type this would be. If it's a wood building, it would follow the NDS, and then the foundation systems are going to incorporate the reinforced concrete ACI 318. We'll be looking at the applicable NRCS conservation practice standards, the 313, the 367, or the 561. Those are the typical practice standards that we're seeing. There could be others as well that come into a particular project. Risk category for loads. We're using risk category 1, which is appropriate for agricultural buildings. Dead loads, we're talking about self-weight of the building. These buildings are light, consisting of the open web steel truss, the fabric panels, associated cables and bracing, typically looking at 1 pound for the top cord, 1 pound for the bottom cord, plus the self-weight of the truss. And then collateral loads or hanging loads, if you will. These are things that would hang from the truss, such as fans, lighting, or other hanging loads. We're typically designing in a 0.5 to a 1 pound per square foot for those. Ground snow load, that's going to be determined for each particular site. And the snow load importance factor 0.8 and the thermal factor of 1.2, those are appropriate for risk category 1 buildings that are unheated. The sloped factor C sub S, we do use a reduction for slope, and that's depending on the slope of the building. Typically, we'll see slopes in a 412 or a 512 application, and then we'll use the slippery roof condition within the snow load calculations. And for areas where ground snow load is 20 pounds or less, we will utilize the minimum snow load piece of them. Unbalanced is calculated as per ASCE 7, applied to the structural model. And I would say that for drift load from higher roof or sliding snow from a higher roof, these are areas of caution. These are areas of concern where we want to exercise caution and maybe bring the truss spacing closer in those areas, or possibly go to a solid roof segment in certain areas that might be getting more of a drift load from a higher roof. And incorporating the solid roof within the fabric roof system is certainly something that we can do. It's beyond the scope of the talk today, but it's certainly something that we have done. Roof live load, we're using ASC table 4.3-1 for that. Wind loads at 105 miles per hour, that's appropriate for a risk category 1 building. Exposure C, a building enclosure category for enclosed sidewalls or sheathed walls. That could be a partially enclosed, or partially open building enclosure category for the wind load design. For open sidewalls, be looking at open or partially open for that scenario. Typical building geometries that we're seeing and that are available for that clear span condition, wind perpendicular to, or the width perpendicular to the ridge, to the clear span. Typical range that we're seeing is from 50 feet on up to 130 feet. clear span and the truss spacing and everything that goes along with that system is kind of taken into account with whatever the span is. In supported frame applications where there are interior columns, the typical range of building width for those applications is from 90 even on up to 160 feet wide. The photo on the bottom left is just an indication of a clear span condition, and the photo on the right is a supported frame with interior columns. Those interior columns may fall along each side of a feed lane, or in some applications, they're further in to the bedded pack area itself. Length of the building, we're saying minimum of 32 feet, no maximum. Clearance height under the truss. This is a key dimension for this building style because of the way that the truss bottom chord comes and meets the column at the sidewall. That's the clearance point, and we're seeing 14 feet typical, but up to 20 feet is certainly also available because of the customizable design and the steel material. Roof pitch. 312 is really the minimum recommended, or recommended as a minimum slope for the fabric roof. Really don't like to see these roof slopes go below that, so that we maintain adequate slide off. 412 and 512 are the typical roof slopes that we see. Other more steep slopes are also available. Truss spacing, 16 feet on center is typical. 12 feet, 20 feet are also fairly common. 12 feet, not as much. We're kind of seeing a shift toward wider spacings, but custom spacings are also available. One thing I would note is we try to keep the fabric spacing equal all the way down the length of the building, including the end bays, because we like the fabric segments to all be the same width when they come out to the job site. Roof overhang, 4 feet is typical, up to 8 feet is available, and really for an extended overhang, even greater than that, probably up to 20 feet with a cantilevering truss. We utilize an overshot ridge, and in sizing those overshots, we're using guidelines by the Penn State Extension. And so this is a slide of those guidelines, number DIP 811. In determining what the opening size is, the throat opening for that overshot, that factor X, really using the guidelines and recommendations of this document. End wall doors are unlimited. The end wall can be completely open. It can be enclosed or anything in between. Sidewall doors are available as well. And this is a situation where we would be putting a header in the sidewall to carry one truss. And then we would hold back 1 foot on each side for anchor bolt clearance and keeping the column, the main building column, from landing right at the end of the concrete wall. And so the photo in the bottom left indicates a sidewall header span that is carrying 1 truss. And so what that ends up being numbers wise, if the frames are 12 foot on center and we're carrying 1 truss, the door opening would be 24 minus a foot on each side, so 22. If it's a 16 on center system, that door opening would be 30 feet as a maximum. And if we're 20 foot on center truss spacing, our door opening would be 38 feet maximum. Once again, a steel header provided over that opening. Sheathed walls are going to be wood or light gauge secondary framing with cladding. Open walls. We still need to provide cables or portal frames for the building lateral force resisting system. The photo at the bottom right shows the sidewall cable that is incorporated even in an open building as it sits on top of that foundation. For foundations, we'll see caisson pier design, straight pier belt at the bottom. This is typically for smaller buildings, continuous wall foundation, or some of the other options that we spoke about previously. By way of fabric properties, this is a slide. I don't intend to go through all of the points on here, but simply to mention that the NovaShield Elite product is the recommended product. This comes with the 20-year warranty. It has the strength characteristics of spanning between the frames as we like to see. And it meets a lot of different tests, ASTM tests for tensile and tearing and other sorts of testing that is done on the fabric material as it's being manufactured and put into rolls and then sent out for actual application to a building. The FR performance, the flame retardant type performance of the product. It does have ASTM E84 Class 1 rating for flame spread and smoke generation. Fabric quality control. For each project, fabric samples are tested and logged as per ASTM D4851, which is a standard test method, or it's a standard for test methods for coated and laminated fabrics for architectural use. And so there's a series of tests that need to be done on the fabric as it's prepared for the building. There's a universal test machine that's used to test fabric samples and strips. There's a test rack for static load tests that are required by that ASTM standard. This is a structural design example that I'll run through quickly here. This is for a litter storage building that was recently completed in Quarryville, Pennsylvania. It's an 80 by 128 building on a 6-foot foundation wall. The clearance height under the truss in this case is 18 feet. Roof pitch is 412. Truss spacing is 16, and the roof overhangs on this building are 4 feet. We use the IBC, ASE 7, and then the PA NRCS practice standards 313, 367, and 561. Risk category 1 building. The loading on the building is as shown, 30 PSF ground snow load that translated and calculated out to a 17 pound per square foot slope roof snow load on the building, 105 mile wind speed, and open sidewalls. Load diagrams on this primary frame. We have roof live load and unbalanced snow load shown here. The unbalanced snow load, something to note is that tends to stack on one side of the ridge. And so there are other load diagrams that would be incorporated into our RISA 3D model, such as wind perpendicular to the ridge, wind parallel to the ridge. They would also be included. In areas where seismic might control the design, seismic loads would be included within the RISA structural model as well. Load cases and load combinations are applied according to ASCE 7. And the steel design that we're doing out of our office here primarily is ASD, is allowable stress or strength design. The steel construction manual is a dual code utilizing LRFD or ASD. Some other notes about the structural design. Member sizes are evaluated based on a unity check value. If the unity check is less than 1.0, the member is acceptable for the given loading conditions. And so the graphic in the bottom left is an envelope of the member unity checks for this project. The legend shows, by way of the different colors, where those members would fall on the range. Anything that's red on a member unity check like this would indicate a member that is overstressed. The bolted and welded connections are evaluated as per AISC, the steel construction manual. These are some sample connections at the peak and at the peak of the cathedral, the bottom chord of the truss, the connection to there, and then where the truss connects to the column. These are 3 areas, but certainly not an exhaustive list of the connections that are looked at within a design like this. The web connections for hollow structural sections need to be checked as they weld to the cords for plastification. And so those things are also part of the structural design. A slide here just regarding behavior of the steel frame and the effect that the moment connection at the eave has. One of the things that I like to do in evaluating a structural frame and looking at performance and just looking at behavior, I like to look at a deflected shape. And so the slide at the top shows a deflected shape due to gravity loads. And the slide at the bottom is a deflected shape due to wind uplift. And as you study that, you can get a sense of which joints are pinned, such as the base condition on the model is a pinned condition. But as you get up into the eave area, it has more of a moment resisting nature to it. Foundation design in our office here, we use RISA foundation software, and we're able to take the base reactions from that frame, from the truss and columns that make up the building frame, bring that down to the foundation level, run this design, looking at overturn, looking at bearing, looking at sliding, and then looking at the reinforced concrete strength design for rebar and concrete thickness. Anchor bolt design. Here we're going to be using a software package as well. And anchor bolt design as of late has become more complicated than it used to be, incorporating more failure modes within the concrete itself. And so we like to use anchor designer software, either by Simpson. Hilti has one of their own as well, and there are some others out there. But we like to use packages like this that easily incorporate all of the failure modes. Switching to some thoughts related to the Environmental Quality Incentives Program, or EQIP for short. As we look at the building just described, the steel frame, the fabric roof, the benefits of those things, it becomes a question, I think, in my mind, and maybe a question for those that are putting forward these buildings to the producers themselves, is how to characterize the building design, and how do we characterize this particular building design. And I'm going to recommend, I'm going to suggest here, I guess, that the steel frame with roof, or the HU steel frame with roof, would be an appropriate category for this building. The fabric has long life, even in corrosive environments. It's tested for quality control per ASTM standards, and the roof fabric has a warranty. The building frame itself is hot dip galvanized steel. It has a warranty for workmanship and has a salvage value even at the end of its useful life. And so this is a snip of the Pennsylvania EQIP categories and rates for fiscal year 2024. And the choices of where to plug in and categorize buildings range from flexible roof to steel frame with roof, and then also the timber frame roof is shown here. And so trying to find that place to locate a building that has this gable style, has this steel frame, and so forth. I think that's one of the challenges. And as I look at this table of where to put it, and I think that steel frame with roof would be appropriate. And so in conclusion, I would just say that steel supported tension fabric buildings have many benefits and good value due to the translucent fabric roof, due to the gable roof shape, due to the hot dip galvanized steel, for the reasons that are listed there. We certainly can have foundations that are customized with options for any particular application. And in answering the question that I raised earlier, yes, I do believe it is possible to create a building system with strength and longevity from a steel frame, versatility from secondary wood framing, and then add in the benefit of the natural light from the fabric roof. And then finally, just in recommendation, considering EQIP steel frame with roof. And so with that, I'll stop sharing, and thank you for your attention.
Thank you very much, Brent. Greatly appreciate that. You know, the slides I have, you also had one more slide, I think, that had your contact information. So if people request, do you mind if I share that?
Oh yes, go ahead.
Sure, I'll share that now quickly, and then if anybody would like the slide deck, I also can provide that. We have several questions. Before we jump into the questions, though, I just wanted to hit from the Pennsylvania perspective on the scenarios. I think a strong argument can be made that steel frame with roof is an appropriate scenario. I would like to run that past our program staff, that they have a lot of say in the payment scenarios and what fits where. But I will say that our EQIP scenarios are not a perfect fit. We don't have a scenario for everything, so it's always best fit. What's the best fit? And I think a strong argument can be made for that steel frame with roof. And I also believe that the resulting incentive payment would be in line with where we would want it to be when compared to the real world costs. So I can't answer or or say the same for other states. There are other states outside of Pennsylvania participating in this meeting, and I would say a good discussion with your programs people and state engineer would be appropriate. And for the Pennsylvania people, I will get you a definitive answer out through the area engineers in the next couple of weeks after I talk to programs people. So with that, though, I want to jump into some questions. Nigel Woodfork from New Jersey, you had several questions, and it might be easiest if you just unmute and ask them. Would you mind doing that?
Sure thing, Tim, but I'll just read right off of what it was.
Okay.
So it was regarding tension fabric roof on steel. Can you speak as to why some regions are slow on the uptake if the benefits overall so clearly outweigh those of wood construction? And so, for example, in New Jersey, we've always just done timber, and I don't know if it's because out of habit or just that we've forgotten how we got to where we are. And maybe it's because historically steel used to cost more, but the market's changed now, so maybe we should start looking at switching. So that's kind of the first round of questions.
So I think that the industry in general, the tension fabric building industry in general, has taken some hits over the years. Within the state of Pennsylvania, for example, there at one time were a lot of salt storage buildings by a particular company, and over the course of time, they were all taken out and they were replaced with wood structures. There were some particular reasons for that, and some particular reasons why I highlighted certain practices in installing the fabric, in holding the fabric within the Keter strip, and so forth. And so I think there is some education that I guess needs to be done just to put the word out that these buildings can be designed for longevity and designed for code loads as well. Another inhibition, I believe, for adopting the building style is having an adequate number of contractors who are comfortable building, and just maybe just awareness of how to put these structures up, and who is out there in the marketplace providing them.
Thanks for that, which kind of tied into the other part, which was that perhaps in the past, people thought of wind and snow load issues as being something that was made it complicated. But just seeing that New York, and I see Bob saying Vermont's been doing them, that I guess those issues aren't really insurmountable anymore. So we don't really need to be worried about wind and snow being an issue for the fabric roof and that kind of stuff.
We really don't, and that's really my role, working with the design, looking at the capabilities for snow, being smart about it. There are some instances where, maybe we wouldn't want to put a fabric roof if we had drift load coming, or maybe we want to tighten up the spacing so that we can mitigate a situation like that. But these buildings are used extensively in Canada, and so snow load really isn't an issue. And then on the wind side, it's really a matter of holding these buildings down and designing for uplift scenarios at base plates and foundations.
Segue into, before I circle back to my own question, but I did see someone else's question since we're talking about it, and I guess it is relevant for New Jersey and our small farms where we'll have tree lines right up near our buildings. So when it comes to the wind, that fancy fabric and the company you mentioned, are these fabrics thick enough now to take, tree debris and stuff flying around on a windstorm, things like that?
So we see a lot of strength within the fabric itself, whether it's hail or projectiles. It doesn't mean that things can't happen. It's one of the benefits of the segmented roof system, that if something were to happen with a puncture or something like that, the one piece of fabric can be replaced if necessary. But it really has a lot of resilience and just the flexible nature of the fabric, and being able to absorb an impact and shed that. We certainly don't advocate BB guns or anything like that, because there are some certain susceptibilities to the fabric, but they're more resilient than you might think.
Oh, that's good information. And last round from me, if it turns out that here in New Jersey we just decide to flip the mental switch, and with the small farmers, they do oftentimes lean on our recommendations, especially because we do have a lot of beginning farmers type stuff. And so if we make the mental switch to just start, starting with the recommendation of going the steel and the plastic, do you recommend the default be the gable style over the hoop style? And I don't know, maybe the gable style like truss setup is a little bit more complicated and expensive than than the hoop steel frame. Do you have anything to say on that in terms of using, going with gable as your default option?
Yeah, definitely for me, the gable is the default option. I really don't perform the designs of the hoop buildings. I have in the past. I've kind of gone away from that just because of the quality that I see is just a step up and better quality with this gabled roof design.
Thanks a lot. That's it for me.
Hey, thanks, Nigel. Might tap you to be a moderator in the future. That was helpful. Thanks. A couple
Tim,
more questions.
I won't be. You can't, because I'm actually switching agencies recently. So.
Well, I'm sorry to hear that.
Yep.
We should chat to the side. Another question: is a lean-to style roof design a possibility with a steel fabric roof? I think probably like more of a monoslope type setup.
Yeah, I did slip that slide in there, just in the under the fully customizable talking point. Yes, we have done a couple of instances of monoslope designs. One of the things that we're seeing there is we like to keep our minimum slope at 312. With the monoslope, perhaps it could be a little less than that because you don't have unbalance coming from the other side. But still, we stay away from the real low slopes that some of the monoslope buildings out there are doing. It provides a nice design. Certainly, it fits that moniker of high, wide, and open there as well. And we're getting good reviews from the producers that are using them.
Very good. Next question: you answered about tree limbs and you answered that part, but what about birds and pigeons? Any concerns with that on the fabric?
Not that I have heard of that birds are an issue with the fabric. Sometimes whenever you have a system that has any accommodation for a bird perch, sometimes you'll get birds with that. And there are some applications of these buildings where they actually go with bird netting on the bottom cord to mitigate some concerns there. But as far as the fabric itself, not that I'm aware of, no.
Okay. Next question, and there's a couple questions in here, and in addition to cost comparisons to timber structures,
Actually, hey, Tim, real quick, because I
Yeah.
meant to ask deeper about that. Can he get into the cost side of things again? I don't know if I really asked about that.
Sure.
Like cost of timber versus steel.
So in general, and my role is structural design and not necessarily pricing out all of the different options. But in general, from my understanding, the building style that I'm describing here today is more comparable to a steel building than it would be to a wood building. In other words, for the steel material for the square footage or the unit cost would be more in line with a steel building package. That as far as comparison, it could be 20 to 25% more than a wood building.
All right. So we mentioned that. Are there other challenges to consider for local contractors besides that cost difference, are there any reasons a contractor might prefer timber even if costs are comparable to steel? Is there a supply availability challenge? Is there a building time challenge? Is there an issue finding skilled labor? Other items you can talk about on that end that may or may not be a challenge.
So I think that as time goes on and as more contractors become familiar and realize that it isn't a scary thing to install these buildings, it actually goes very quickly and very well. I think that that's going to help mitigate some of those concerns. There are a lot of contractors out there, and I mentioned this in the versatility of wood and kind of easy to work with. They're set up for wood. They have tools for wood. Maybe they have their vendors for columns or different trusses and things, and they're just more comfortable with that building style. This type of construction would utilize someone who has either skills in steel erection or interest in steel erection. Certainly gets pretty high in some of these applications, and so lifts are needed to put them in. For the real large clear span buildings, it could be a crane application to install some of the trusses and things. And so I think it's just allowing some of the companies that have contacts with contractors, allowing them to make those connections and bring them into your area.
Very good. And we had a couple of comments. Pete Berenstappen mentioned about anchor bolt designs, and he appreciates that. And then Bob Thompson from Vermont mentioned about having installed a few up in Vermont and using the best fit in their situation was timber structure. So that's good info, but sounds like they didn't have steel frame in their scenarios in previous years. A question though, impacts to the warranty or lifespan, anything from heavy snow or ice loads or anything else that might impact or negate that fabric warranty?
No, as far as negating the fabric warranty, if the building is designed according to an engineered design, no, to my knowledge, the fabric warranty is not voided.
Okay. Next question. Any quality assurance tips for those inspecting the building construction? This is something that was in the back of my mind too. When you start mentioning welded connections, that's not something we typically have a lot of experience inspecting, at least in Pennsylvania.
Right. So the experience that I have, and you see it on the acknowledgement slide there, a lot of the photos and pictures from today's presentation were courtesy of We Cover Structures, and just speaking from the perspective of that company, when their trusses arrive on site, all the welding that's done on the building is shop welded, utilizing certified welders in a shop that's been certified A660, and so forth for the welding certifications. And so when these components arrive on site, they are bolt together at that point. And so it goes up quickly. It's not a difficult thing to do. It doesn't require field welding. In fact, we encourage not to do any field welding because these are hot dip galvanized components, and field welding burns off the galvanizing, and then it needs to be replaced by a cold galvanizing, which it's preferable not to do unless it's absolutely necessary.
Very good. And last question, I believe, does Ridgeline make site visits out to do any inspection? Is that something that you help out with? I think with NRCS, we're always looking for a certification of the completed work, and this question's getting at that.
Right. So each application will be different, I guess, and where the project is located and who we have in a particular area. But we've been successful in Vermont and in Pennsylvania as well. and looking to do the same thing in some other states here, certainly Indiana, where we can work with the local NRCS field office, where we provide the stamp drawings and details for the building and foundation. And the local field office, if there's capability, if there's a willingness there, we can create an inspection partnership where I would be coming to do a final, or someone from Ridgeline would be coming to do a final on that project and submitting the final checkout, the as-built and that final certification report.
Okay, very good. That concludes all the questions in the chat. I guess one more question. This seems like it could be another tool in the toolbox. And as we discuss options with landowners, if a producer has interest in finding out more about this type of roof option, where do they go from here? Do they contact WeCover? Are there other manufacturers out there as well? From NRCS, we can't endorse any one specific manufacturer.
Sure.
Do they
Sure.
contact you? Yeah, so that would be a last
Sure.
question, I think.
I'd say feel free to contact my office, and we'd be happy to redirect to someone that might be in their particular area.
All right. Excellent.
Tim?
Thank you very much. Yes.
Nigel here again. When one is perhaps moving about job-wise, the filter gets lost. But I will just say, is there any way from because I'm on the cost share team stuff, and is there like any way these companies and their cost estimators could be put in touch with the HQ folks for historical prices on these things? Because as he pointed out, the steel cost share rate is still quite similar to the wood one, and we know the steel is more expensive, and perhaps 25%. So it seems like it would just be a few documentation packages away from getting this stuff updated. Otherwise, New Jersey will stay in timber realm because we cannot afford 25% cost increases. We can barely afford timber roofs as is. So that's where I'm driving at there. But you're a state engineer, so maybe y'all folks could push things around.
Yeah, if there's any way that I can facilitate some of that, I'd be happy to try to do that.
Yeah, Brent, we can touch base outside of this meeting. It's always a challenge wrestling with the payment schedule situation, and we always have interest in trying to have payment scenarios that are reflective of real world costs. We typically target 75% and 90% for HU scenarios, but that's just a target. And so if you have some cost data that could be shared, I can certainly take that to the national office. Another question. Don't we pay based on least cost alternative, just pay a membrane roof based on timber prices? Pam Karshner, you're going down it's a valid question that I think would be best answered outside of this. When it comes to least cost alternative, that's a Pennsylvania specific item, and we have utilized least cost alternative when determining whether or not a roof payment should be made or a vegetative treatment area payment should be made. And we have not used it to say, hey, a timber roof would be cheaper than a steel roof. So we can have more conversations about that, but it would not apply to what option the landowner would prefer. It would in Pennsylvania apply to whether a roof payment could be made or not. So with that, good discussion. Thank you very much, Brent. Greatly appreciate it. And you may get some questions after the fact. I hope you don't mind. But with that, we're going to transition to a lunch break. I have 30 minutes on the agenda, so we're pretty close to our time. Let's get back to the meeting at 12:20. That'll give us a solid 30 minutes, and we will jump into a case study with Pete Vanderstappen at 12:20. So thank you very much, everyone, and we'll get back together at 12:20.
Hey, Tim, I'm ready to share anytime.
Oh, you can share your screen if you'd like, Pete. I'd like to wait till 12:20 to start your
Yep.
presentation, but go ahead
Well,
and do that.
We can leave the agenda on here for another minute.
Okay.
Hey, Tim, can you see my presentation?
I can see it. Thanks. Get going in 1 minute, Pete.
Very good.
All right, welcome back. I hope everyone enjoyed a quick lunch. It's 12:20 on my clock, so I'd like to get going again. Our next presentation is going to come from Pete Vanderstappen, a name probably many of you recognize. Pete, for those that don't, is a retired NRCS state conservation engineer, and he retired, I think, about 2.5 years ago. At that time, Pete had 45, 46, excuse me, years of experience working with NRCS. And while he did spend some time out of Pennsylvania, a bulk of his career was working with ag conservation and ag waste management systems in PA. And since retiring, he's joined the ACES Retired Workers Program, and he works both with the National EWP, the National Emergency Watershed Program team, and then also with the PA NRCS Engineering Department. So, Pete, with that, appreciate you presenting, and the floor is yours.
Hey, thanks, Tim, for the intro. And looks like a great day. I'm impressed. We have over 100 participants, so that's a good sign that people are interested in all the topics you selected today. So I'm doing a short presentation on something I thought was rather interesting, and I think it's going to play into some opportunities for folks that are thinking about, maybe it's rare the guys actually switch from sand laden manure and bedding to manure solids, but maybe if they're getting into covers and stuff like that, they may need to think about getting out of the sand business and going to manure solids, recycled manure solids. And maybe this is one idea or one avenue that might make them think about doing this. So here's a little background. It's a 335 cow dairy located in near here, central Pennsylvania. Simple stuff. They scrape the manure to a cross channel. It gravity flows to a holding tank. The waste in that holding tank are agitated and then pumped up to a bare manure separator and dried using a modified Snoop's soybean roaster. So that's the new intriguing aspect of my presentation. Instead of just separating the manure solids and elevating up and stacking in the barn, and what they were doing was every day they would run green manure solids and bed those the next day. They did not wait for the material to heat up or anything like that. The liquids returned to a single stage HTP storage. The system is run 5 hours per day, 4 days a week, Monday, Wednesday, Thursday, and Friday. The pile of material they generate out of that is used to bed 260 cow stalls. And you saw they have 335 cow dairy. So they actually are pushing, 40, 50, 60 cows extra in that. They're really pushing the limit on that facility by having excess cows in there. But it is a nice, clean situation. And the farmer really does a lot of bedding. The stalls are groomed on other days. So the day that they're not bedding, they run a skid loader through there with a grooming brush on to level out all the facilities. And after, as each cows are moved out of each pen, they muck out, if there's any manure in that actual stall, they'll muck that out every day. So they're really looking at maintaining dry areas and great cow comfort. And some of the excess material is used for dry cows and bedding. But we're going to go through all the pictures and show you what's going on here. So here's their farming operation, just a general overview. Left side, you can see HTP line storage. They have a little temporary holding concrete tank there. And I have that separation shed, which looks like the wing of a bigger building, but that's where the bare separator is. And then they have a manure solid storage shed, and that's where they put the dryer in. So that's their main part of the operation dealing with this. They have a lot of other facilities there, but that's the main thing we're focusing on today. So we're going to start at the low end here. This is their temporary, you see the 24-inch pipe coming down. That's where they flush the manure down from the barn. And this is after they've ran that system for about 5 hours. You can actually see the impeller blade there from the agitator and pump. So they get about 4 or 5 feet of manure buildup every day. And then they run it for 4 or 5 hours to process all that waste up to the separator, and it flows back into the storage as shown on the right-hand side of that photo. Try to do some components to get started. The left thing here, which I thought was really impressive, is your primary control panel. And this was an expensive add-on to the system. But the beauty of this control panel is it's programmed specifically to their site. And they can turn off and on the agitator, off and on the pump down below. They can turn on the bare separator, and they can also turn on, there's 3 motors associated with the roaster and the blower housing for this cyclone fan and running the other fan. So there's a bunch of motors running here. This one control panel allows them to start up the entire system, kind of run on its own. But here's the key. If something fails, if the agitator pump would shut off, if the bare separator would quit running, if the blower would quit blowing, any part of these activities will quit, the entire system shuts down. So they have a really good safety protocol here that they don't have to worry about one thing running and something else failing and just keep on going. So it cost them significant dollars to do that, and we'll show that later. But it was really critical to make this system go. Here, a first picture on the right-hand side is the bare separator. I will tell you that one thing they did find out was to find the material coming out of separators is what they always want. Low moisture and pretty fine particles. But to dry the material in this type of dryer system, they actually put a larger screen size in to get a little bigger material, which actually would dry better. It probably increased the moisture content a little bit, but the farmer did say it's saving about, I didn't even consider this, he saves about $1,500 a year because the screen doesn't wear out as fast. So it's kind of an interesting savings. Up this is an overview of the system, and kind of jumps out in front of you is the foreground. You do see the green elevator. That takes the finished product and just elevates up to there's a system in this particular barn that runs back and forth, and it runs about 10 feet